Alrighty, hopefully we're live. It says I'm live, so hopefully all good. Hello everybody, good evening. We've got quite a few people waiting in chat, that's really cool. Couple of changes. First of all, my internet connection at the moment is stable and actually running at a good speed. So YouTube for the first time is happy. No idea if that is going to make a lot of difference for you guys, but hopefully there should be a bit more quality in the stream, and hopefully the visuals will improve a bit that way. And I have a new camera. Pretty happy with the camera itself. It's a Razer Kiyo Pro. Software is horrible, and I'm fighting the software. So I'm pretty sure that the camera is not set up at its best quality settings, because whenever I have the Razer app working, I can't get the bloody thing to show up in OBS, but I can have all the nice features turned on. And the moment that I close the application, it shows up in OBS, but it doesn't have all the nice little bells and whistles. So yeah, that's probably user error on my part, but yeah, Razer, your software is a bit weird, so I'm not quite sure what to make of that. We'll figure it out eventually. Besides, we have a little postcard thingy in the bottom. The quality doesn't matter that much. Although I do want to at some point get used to switching between full screen and developer mode and being able to move the camera around. And then it is nice to now finally have a camera that in full screen mode actually looks good and isn't completely pixelated and horrible. So, welcome everybody. We are going to have well, we're basically going to pick up where we left off in my last stream. Obviously, in my last stream, we spent a whole bunch of time on looking into one of the rendering effects demos that I made, and really went to town on that one. And then we spent some time just talking. But my original plan at that point in time was to actually build a rendering effect from scratch. And I want to build something that is a little bit more generic and easier to use, as a prelude to something that I want to build later on that's potentially going to be part of Godot itself, where we have a material-based rendering effect. And I think that discussion was actually in the that probably was in the rendering effects itself. Let me see. Yeah, I believe that was, that was part of the discussion that I had with Kebab Skull, who was sort of saying like, hey, I just want to be able to just manipulate the end image. So I would like to have just a rendering effect where I can basically set up a material with a shader, and that shader was just applied to the whole image, and I don't have to worry about setting up the rest and doing all the boilerplate work. So tonight the idea is that we build the basis of that, and we're not going to go all the way down to creating material support, because that would require changes in the engine itself, in Godot itself, in the core. But we can do something that we can at least write the shader inside of the editor and make it automatically update, and take away some of the pain of having to do everything manually. We can sort of experiment with it and see how flexible we can get it, and then eventually I can move that over into the Godot core, add material support to that, or add the material layer on top of that. And the end result, hopefully at some point, is that you can then even do visual shaders to do post effects. That will be really cool. That's the hope that I'm having, that we can end up doing at some point. Don't hold me onto that if I don't actually make it, but that's my thing that I want to try and get to. So I'm going to use this demo project that's on the Godot demo project as a PR here. It's very unfinished because I'm actually not very happy with the where's my Godot not running? I thought I had Godot running. I'm not super happy with the samples that are in there right now, but yeah, it's a start. I still need to find some really good examples of rendering effects that I would like to put into the demo. Obviously, the radial sun rays that we looked at last stream, that one's actually really good. I'm quite proud of that one. But that one is kind of big and has a lot of, it's got some third-party assets that might be CC4, but they're still someone else's assets. I'm not quite sure if that is suitable to include in our demo repository. That's it. Where is our demo repository? Demo. It's no longer in my list. That's very funny. Well, we can re-import it. Sometimes I clean out the import, and I guess I did that at some point in time. So this is in project, and then it is in Godot demo projects, and then we go to compute, and then I think it's in post effects, and that's where it is at the moment. Okay. So when we're looking at this sample project, you can see that there is a screen space reflection system in here. It's not super good. It has a lot of artifacting, but as a start, I kind of built this with the idea in mind that I wanted to experiment with something called stochastic screen space reflections. And the main difference between the screen space reflections that we have embedded in Godot and this implementation is that there's a smarter way of stepping over the ray to find where it's hitting something. So instead of checking every fragment over the distance of the ray, this is checking higher MIP levels of the depth buffer, and therefore it can skip over multiple pixels whenever the ray goes over a part where all the pixels are above or below the ray, basically. So it makes it a lot easier to step through something like this. So, but there's a couple of things where it's not working the way that I thought it was. So I'm still trying to figure out where I'm going wrong with that. Hey, George, how you going? Nice of you to join. It must be very... No, it probably is early in Portugal. Is it? I don't know. Are you guys waking up in Portugal right now? I don't know. What time is it over there? Here it is almost 9 p.m. So, yeah. Okay. So yeah, this is just an experiment that I was working on, and I'm not even sure if this would be something that I want to have in the demo projects, but I was just playing around with it. It is a nice little effect because it's also a multi-stage effect. So right after the def pre-pass, we do our def MIPS. So it creates a number of slices for the def MIPS, and then actually in the middle of the process. So it's actually after we render the sky, but before we do transparency. We then do the whole SSR steps in this process. So it's a nice little effect. There's a couple of good things in it. So there for that reason I might keep this if I can figure out the bugs that are in there and make it better. But yeah, it's just an experiment that I was working on. The other thing that's in here, and that is something that I need to fix up because Anser rightfully pointed out that I did it way too simple. Oh, 11:55 a.m. That's not bad. So you're about 9 hours behind us. Yeah, that's doable. Okay, I should actually have known that because my parents are in the same time zone. So yeah, there's that. So when we're looking at our world environment, there's actually a second effect in here, and I don't know if I'm still listing everything. Yeah, there's a grayscale in one, but that one's turned off. So yeah, I've got the shader that turns everything into grayscale. That's kind of funny. But yeah, I need to do a fix in that one. So we'll quickly do that before I forget. And it's actually not in the script. Just looking at the grayscale script, it's very similar to what we're looking at last stream, but this just does one step. So we obviously call our initialize compute on a render thread, and on our exit we nicely free our shader. In our initialize, all we're doing is compiling this shader, and then in our render callback, we're getting some information here that we need. And then we do our little compute pass. The other thing, of course, is that we have a script file. Now, when we click on this one, all we get is this compiler test. So Godot currently doesn't have a way to edit these shader files. You can drag them into here, and it kind of works, but I found out that Godot can get a little bit confused, to say it mildly, or to put it mildly. So, okay, that means that I am going to have to look if I still have that here. There we go. It's all good. So we should have our grayscale code here, and this is about as simple as a compute shader can go. And of course, I'm mixing tabs and spaces again, so let's fix that up. That's good. And all that Ansir correctly said is, you're just doing max. That's really dumb. You need to do something like do a proper calculation. So let's put the proper calculation in there. And that's just a weighted calculation of the RGB channels that then turns to grayscale. Now, the downside of this is because that should be a plus, sorry. Because, there we go, now it goes right. Because we are compiling our shader on our init, we're only compiling it when the 12 p.m. Oh, so you're pretty much in the same time zone as Alex, which makes sense because it's pretty much the same part of same what do you call it? Longitude, latitude. I always mix those two up. One of those two. Same longitude or certain latitude of the of the world. UK and a little bit more south Portugal. If I remember correctly, it's been a long time since I lived in Europe. Anyway, so as I was saying, the problem that we're having here is that on the init function of our effect, we are compiling our compute shader, and of course that happens way at the start when the environment is loaded, so it doesn't update. So nothing actually changes in this view, even if we turn our rendering effect on. It's still exactly the same. Maybe I should take a picture of this so that we can see how much it changes once we reload it. Why does that not work? There we go. Boom, I hope that didn't screw up my recordings. I'm sure that will be fine. Now, it is possible if I save this and then close it, that is enough to redo this. Yes, it does. And as you can see, everything is a little bit more colorful now, because with the max function, you can see that all these different colors, these had, if I turn that back off, boom, we had all these different colors, but they're all sort of the same weight, or sorry, the same values, just, different channels. So they all kind of become the same gray color. But when you have that weighted change, you can actually see some more variation in colors, as things have actually a darker color for the eyes. So it's pretty neat. So that was just a small change that I wanted to put in here. Sorry, I'm very thirsty. I've been doing a lot of talking these last 10, 20, 10, 12 days. Yeah. Okay. So yeah, while the screen space reflection kind of works, it's not a not a good implementation yet. I need to work on that some more. But the grayscale thing is now working the way that it should. So pretty happy about that. So before we continue, I am going to go and quickly push that in. Boom. Amend that. There we go. I'm not too worried about formatting and stuff yet. I just want to go and make sure that that is updated. Okay. And where are we here? And I can say answer change to that grayscale logic. We use the phrase, yeah, the max appropriate. The max thing is just just laziness, really. When you just quickly want to do something that kind of becomes gray. But yeah, this looks way better. This yeah, I like this this version of it. So, okie dokie. What are we doing now? We are going to go and create a new rendering effect. Yep, exactly. We're still discussing time zones in chat. So yeah, we're going to build the new rendering effect. I'm going to leave this implemented as is. But we'll make the new one, and I'm not sure if I'm going to keep this in this demo, or I'm probably going to split that out to a separate demo, or even just like I said, keep it as an example for building a real implementation inside of Godot for this. But it is important to know that we're now going to create something that is purely meant to do a post effect and work with the basic inputs that we have available to us. So we need to create a nice new folder for this. Create folder, and we are going to call that shader post shader. Boom. And I'm going to go and create a new script, and I'm going to call that post shader.gg. You just do great. Oh, and it doesn't go there automatically. That's a bit silly. Okay, and there's our shader. So stop doing that. For some reason, Windows, I don't know if that's on my Windows or that I've got something crazy installed, but from time to time it just brings my file explorer to the front. It's really annoying. Okay, so we are going to start copying some of the stuff from here, but not all. Excuse me. So, because we're going to do this quite differently than the way that it works here. So obviously we want to go and extend from render effects. So we're going to go do that here. I'm going to give this a class name. Good question. How did I do that here? Rendering effect grayscale. Should I? The problem is that it's a long name, and I keep having a problem that when we're looking in the inspector here, is we can't really see what the individual things are. We have to really make it big to see it. For some reason, it's wasting a lot of space here for just the numbering. I don't know why. I guess because we're nicely halving that column, and we want everything to look aligned. But as far as I'm concerned, it can all just end here. But so I'm actually thinking about flipping it around. So maybe we're going to go and call this one post shader RE. And I like kind of shorthand rendering effect because, why write it out all full? That doesn't really make much sense. Okay, so, all right. Now we're going to go and do the same init because that's the bit that really shouldn't change. So that's all good. And we're going to go and already, for that, I do want to go and get the rendering device. And I'm actually going to grab the rendering device. I'm actually going to do that here because even though we shouldn't be calling the rendering device from the main thread, we can grab it. It's not like it doesn't work. It's just it's not safe to do everything from the main thread if you're using multi-threading. But we can grab it up front so that we don't. So I'll go and define that here in this case. We don't really have to always do that. Because again, the init will be the very first thing that we run anyway. So I'm going to copy that because I kind of like making that difference, is that anything that we want just in the normal line of work we put up there, and anything that actually gets executed on the rendering thread we put separate. It's just management. Just makes it easier. Not going to worry about those. I am going to copy these two because I know that I'm going to need that. So there we go. We're going to put those in there. And then we're just going to copy this little bit because we know that that's stuff that we're going to have to implement. And I don't really need all this comment stuff in there. That was fun for the first ones, but I don't think that's really that necessary here. Okay. So okay. I actually want to also do in here, because in this case, we're not going to compile our shader right away. We're going to trigger that based on what you call it. Actually, that's kind of good. I think I actually want to probably do that. You want to do it in render callback? No, we wouldn't want to do that in render callback. That's a good one. In what order does things happen? That's something that we're going to have to figure out. But yeah, no, I think I will do it like that. So I am going to say here, and pipeline is valid. There we go. So what we're basically saying here is if we have a rendering device and our pipeline is valid, and we double check our callback type, then we're going to go and process our post effect. And that means that if we, for some reason, have things not valid, then or not compiled, then it goes wrong. And the reason that I'm doing that is because we're not going to compile this right away. We're going to compile this when we have a shader. And in this case, we're actually going to go and turn that. Oh, I'm going to left that over here. We're going to turn that into an export variable. DLSL shader. That's going to be a string. And where it is going to go in. Well, we're actually going to keep that. Where are you? Where's my... Yeah, that's what I was looking for. I'm just going to go and... No, I am going to go and copy that in. Does that work in Godot? Does it allow that? Looks like it allows that. It's pretty cool. So what are we going to do here? We're going to actually keep the standard stuff in here. Yeah. Okay, the code we want to execute. And I'm actually going to remove that bit. So here we're basically just going to say that our default one has some default code in there, which is really cool. Know what export is without an E. Well, that kind of makes sense. There we go. So we do start with a default shader in there. So in theory, you know, we always have a shader that at least works, and it doesn't do a thing. It reads the color and it writes the same color back out. But it gives you a template. So, and with that, we do have our starting point. We're not actually executing anything. That's really good. So I am already going to be able to make that. Do I want to already do that? No, I don't want to make that a tool script just yet. That's fine. And that's just going to mean that it's also not going to be enabled, or is it just not going to execute this thing? Just going to mean that it doesn't have anything initialized, so that's all fine. So we can actually go into our rendering effects, and with that, I want to actually turn that guy off. We're not going to do anything with the grayscale. We might go and do something with that again later. I'm happy to keep my screen space reflection stuff on there, but we're going to go and introduce our post shader. All right, so now we have our export, but that's not a really nice way to edit that. All right, so let's go and see how we can make that better. And for that, we do docs export variables. I always forget which one that is, because then it always goes to the export help. Oh no, it is for scripting. So that might be what I'm looking for. There we go. Because there is a hint that we can do here that gives us the ability to actually get a big and edit thing. Which one is it? Not enums, not arrays. Do we not have a hint for that? Do we need to do it the other way? That would be really dumb. And how do we get an export and mark it that we want to have the big editor? Because, yeah, I define that as a string. That's fine. No. Sorry, I'm just having a look at. Oh, there is an export multi-line. Really? Why is that not in the help files? That needs to be added to the help. Thanks, guys. There we go. And now we have, boom, we can edit that thing a bit more easily. And that's exactly what we wanted. So the other thing that we need to do here is we need to add a setter. Now, how do we combine a setter with a default value? That's a good question as well. Okay, and did they have any examples in here to do a setter? I'm pretty sure we don't. Okay, so I am going to assume that I need to do that before. Do I need to do that after? I probably want to do that after. Set value. There we go. And then GLSL shader is value. Cool. That works. And the reason I want to do that is whenever we change the shader, I want to start recompiling it. However, we need to go and do that on the rendering thread, which is really interesting. Now, the important bit to know is that when we are looking at the code colon render thread, this, if we're not doing multiple threads, so if we're not having our separate render thread, but we're doing everything on the main thread, this is executed right away. But when we're executing it on the main thread, this call will not be executed until we have processed our first frame right before we start rendering our first frame. So it wasn't a doc, so I was just looking over it. That's really good. Where was it then? Where did I not see it? Export. Export, multi. I'm blind. I am absolutely blind as a bat. Absolutely. Oh, that reminds me. I also need to go and copy that because at the end, we obviously want to do that. Now, one of the things that I am not sure about is whether this gets executed before this. That's another interesting thing, especially when it is changed. So, um, hmm. For that, what I'm actually going to do is I'm going to say, this is an easy way to ensure that. I'm going to add a variable called shader dirty that I mark as true whenever I need to recompile my shader. Now, I'm going to assume that right at the beginning, that is the case, because that means that I can knock that off in the init and then make my shader not dirty. But I can also now do over here that if it is not marked as dirty, then obviously we're going to say shader dirty is true. And at this point in time, we're going to trigger our shader compile. Now, are we going to do that like this? Because when I'm typing, it might keep trying to recompile the shader. And do we want to do that on every character that we type, or do we want to go and postpone that? That's a good question. And what is a nice way of doing that? That's hey Stefan, how you going? I shouldn't say hi to Game Dev, Chris. How are you guys? Yo, what's
I
up?
think something's wrong with the computer.
Why?
They just tried to boot up Rock Life, the Rock Simulator, and it was lagging like crazy, and it crashed.
It's probably because we just reinstalled it.
I didn't even know that was physically possible.
It's probably we still need to install the latest drivers and that thing.
Yeah, it's having serious problems running Rock Life, the Rock Simulator.
I'm not even sure why you're playing that.
Terraria was lagging a bunch, so I wanted to see what happens if I.
All right, so we're just not done with that computer yet. My son's computer blew itself up earlier in the week, and we just reinstalled Windows, but I haven't installed the drivers on it yet. So he's having fun. Okie do. We're just going to start doing it here, and I am going to make a remark here, and I'm going to say, if in editor, we should delay this in case the user is still typing. All right, but for now, we are going to go and say, compile shader. Actually, I'm going to make that do compile, or what's the right word for that? Yeah. I'll just go and do it like that, so that's fine. That means that I'm also going to go and take that off here, and we're going to go and obviously, create that function. There we go. And all that this one is going to do, should I put the dirty in here? I'm actually going to go put the dirty in here. So basically that is where we trigger. That's why I'm now make shader dirty, because it's actually not compiling it. It's going to trigger the compile, which also means that potentially we're going to put the delay in the make shader dirty code. However, what is going to happen in here is we're going to go and call that, but we're not going to call that initialize compute. We're going to go and say that's going to be our compile shader function, which we are now going to go and move over here. And now is an interesting thing, because do I therefore need to put our shader dirty in a mutex? probably I do. And the same with our shader code itself. That is a really good question. Hey, look, reading legs. No worries, all good. Stefan, yeah, well, you know, that blew up. No, I think the Rock Simulator was probably just crashing because it's just a clean install of Windows, and that computer was still running Windows 10. I need to upgrade it to Windows 11. But it means that he's running on a really terribly old NVIDIA driver, so I need to put. I need to finish setting up his computer. That's really what it boils down to. I haven't had any time for that. I've been well, I only just got Windows up and running like an hour ago. So oh well, you know, we'll get there. But yeah, it is kind of hilarious that he got the computer to crash on Rock Simulator. How does he do that? Anyway, so good question. GD script mutex. All right. Um. Yeah. So just define that as a mutex. It's a resource. Okay. I don't know if I need to create the new one. So for mutex new doesn't seem to be complaining about it, so I'm pretty sure that's good. Which means that obviously here we need to have a mutex lock, and then here we do a mutex unlock, because it's really about, are we accessing it from the other thread? In this case, this should never be locked, because we are only calling make sure shader dirty if our dirty value is false, else we're not getting in here. And then obviously we're putting it on the thread. Now on the thread itself, we're gonna unlock it. So that one we are gonna do on a mutex, which is fine. And then here, because it's only if we want to have, so maybe we need to just move that into a temporary variable. So same thing, because we might be running our code for compiling our shader, and we'll want to go and wait for that. Is dirty, is shader dirty, mutex unlock, dunk, and then this just becomes we're checking if not dirty. And again, if it is dirty at this point in time, and we happen to be compiling, and by this time it's no longer dirty, well, is that? Yeah, that is, I guess, the risk, but I don't really want to encapsulate the whole thing into mutex. Yeah, I'm probably being over paranoid with that one. Yeah, because if it's already dirty, but it's actually compiling, do we have a chance that we're going to miss the last compile state? In this case, that's a good question. I guess the way that we can, or the only way that we can really have the most luck or most chance that that won't blow up on us is to make sure that we are going to do this right at the start, and we're going to go and put it on false there. Probably overthinking it with what I'm doing here, but that's all right. We're not running a multi-threaded anyway, so I'm probably overdoing it anyway. So, hey Ishmael, how you going? Yeah, well, you know, would have loved to put Linux on that machine, but 90% of the stuff that my son needs only runs on Windows. So there's that. Hey, Lucky, how you going? Alrighty. So let's go and compile our new shader. And for that, we can go and do, actually, that's a good one. We probably need to get rid of it first. So obviously, we're going to say, boom, out with the old, and then in, but we're obviously not going to go and load a file here. Then instead, we're going to be using our shader code. And that's the other thing that's interesting. Well, something that I guess we can do here is removing that also into our Mutex. Yeah. And then that means that in our Mutex over here, starting to wonder if I should be doing that. Yeah, it doesn't really matter. Yeah, we're gonna go and shader code. We're just gonna go make a copy of that so that, you know, now we have a copy that we're pretty sure, well, that we know for sure that isn't going to be modified while the next session runs. And again, this is way overkill because it's only really in the editor that this could run, and the editor doesn't, I don't think the editor runs in multi-threaded mode anyway, so I'm probably really over-engineering this at this point in time. However, with that, we should be able to do that. We should be able to get rid of that, and our shader code should be compiled. All right. But the other thing that we obviously want to do is we want to do shader is valid. We want to create a pipeline. And probably if it's not valid, we might want to throw some warnings or errors, but I'm going to put that here as a remark. I'm going to say if shader didn't compile, you log some sort of error or give some sort of warning. UI. I think that is good enough for what we're doing right now. So, hey, Ishmael, I don't know if you've been paying attention to anything that we're doing on the XR side of life, but Malcolm is making a dungeon game. Looks a little simpler than your dungeon game, your RPG. But yeah, it's kind of neat what he's doing with it. You should check it out. It's fun. No, are you guys still working on the RPG? I haven't really been following what you guys are working on at the moment. So that should, in theory, compile our shader. All right, provided that we have a shader, which means that we don't need pass there anymore. So well, do we have all the parts for the shader? We have that we can set the shader. If we set a new shader, we're gonna mark it as dirty. Then if it's marked as dirty, we're gonna trigger that on the next frame that we render, that we're gonna compile our shader. That happens on our rendering thread, if we have a rendering thread. And here, obviously, oops, we are now, what did I just, oh, I just folded it, okay. So here now we're going to make a copy of our shader, because obviously, in theory, we could be processing the next couple of key presses while we're still rendering our frame, if we are running in the multi-threaded code. So we want to go and make a copy of that while our mutex is locked. We can then set it dirty, and that's there. So that was the thing that I did not like about what I'm doing here, because here I'm setting it, and I really want to make sure that it's marked dirty at this point in time. Because if I do this first before the one that's already running, then it's fine. Yeah, I'm going to change that. And it's already dirty to begin with, so I'm not worried about that. The only reason why I want that to be a function is so that I don't have to duplicate that. Okay, so let's go to this. And that gets rid of that. So now we know that setting the shader and making sure that that is dirty happens in a mutex block, and setting it as false happens in the same mutex block where I'm getting a shader. So we can't have a situation where I've got a new shader, then this runs, and then I've got the situation where I'm marking it dirty and running it again. Or the other way around. Don't know. There was a thing that I was thinking about where, in theory, it could lead to not recompiling the shader, because it was recompiling it while you're setting it. That's a situation that I'm trying to avoid here. So I think that's good. So in this case, obviously, if it's already dirty, then is dirty will be true. Here we're going to assign true to something that's already true. That's fine. And then obviously, if it's already dirty, we're not going to call our function, because we've already scheduled it. If you're not on the multi-threaded renderer, this will immediately cause it to compile, and it would immediately be undirty or no longer dirty again. So the only thing that we're really missing at this point in time is our delay. I think that's kind of cool. It's all Mikey's fault. Of course, it's Mikey's fault. Anyone else excited that the Godot develop? Yeah, isn't 50K amazing, Seven? That is just, yeah, that's just absolutely nuts. Plus, you know, all the one-off donations that we've had, and then obviously the 100K from Terraria being you know, being the one that's in the spotlight, because that's just absolutely insane. So yeah, it's been a weird 10, 11, however many days it's been. But at the same time, I'm also very glad that that Unity came out with the news that they sort of backpedaled on a lot of stuff, because yeah, like I've said before in my previous stream, I would not want to be in the shoes of a Unity developer who was actually affected by these policy changes. Yeah, because you know, there's plenty of Unity developers who this would hardly have had an effect on. But those that were affected were very affected. So yeah, that's especially for us indie developers, it was a bitter pill to swallow. So yeah, I'm very glad that that's all been. Yeah, indeed, never liked Unity more. So yeah. Oh, hi Tamil, by the way. So yeah, I'm glad that's it, and it's also the just the impact for everybody feeling anxious about what the future holds. It just it would have had a really big negative effect on our industry, because for a lot of people, switching over to another engine just isn't a um, isn't a realistic possibility. If you've just spent 3 years building your game in Unity, you can't suddenly just decide like, oh, we're a year away from releasing our game. We are one of the people who will be very negatively affected when this new price change comes in. Oh, let's take another 4 years rebuilding this into Godot. That's not um, a realistic scenario. It's just not possible. It's so yeah. I'm really happy that that's all gotten resolved. Yeah, the splash screen. I think from all the painful things that happened, the splash screen one was, I think, the one that we had the most fun with, because the splash screen in Unity is so anti. Um, it's very negative PR for them, not just in the sense of they're being very stubborn that they don't allow users to remove the splash screen. It's also that the people who were forced to keep the splash screen were also the people who were making shovelware. No, it didn't do well. That's too broad to say, but the people who make crap little stupid things with Unity that they sold for peanuts, and it was just about making a quick buck. You know, those people were among the people who were forced to use the splash screen, which will only be bad PR for Unity. And when you then compare that with Godot, where you can just go into project setting and boot splash screen and say nope, and it's gone. Um, and instead of people turning it off, most people go, "Hey, I want my own little splash screen." To the point where Kenny and lots of other people now have packs of different splash screens that you can choose, which is absolutely cool. Stefan, I agree. I do not see how Unity can claw back from this. They there will be people who are so used to Unity who are now sighing a sigh of relief and sort of going like, crisis is over, and going back as if nothing's happened. And in a couple of years from now, when Unity finally, you know, try something again, um, they're that's their own fault. But there's going to be plenty of people who are on the Unity or are using Unity who are going to go like, okay, that's just the final straw. I'm going to finish my game because I have no choice. But the moment that I finish my game, I'm going to switch to something else. And of course, the funny thing is, and this is the thing that I really don't get about them, absolutely don't get about this decision that they made, is they've woken everybody up, not just to what it means to be at the whim of a company that makes these sort of weird choices, but also there are so many people out there who until 10 days ago had heard about Godot, or maybe hadn't even heard about Godot, but they probably had heard about Godot. And the reputation that we had was we're this little toy engine made by a couple of hobbyists. Um, and it's fun, but don't really take it seriously. And this has caused a lot of people to have a look at Godot. And while there are definitely people who have looked at Godot and sort of going, well, this is not yet what I need. It's not good enough for what I want to do, but it is a whole lot better than I was expecting. And by the time I finish my Unity game, Godot will have matured more. I'm going to give it another try. I'm going to have, in 1 year's time or 2 years' time when I finish my game, I'm going to first look at Godot, and it might still not be what I want, but I'm going to look at it. Then, of course, there's these legions of people, especially indie devs who are focusing on 2D, who are now trying Godot and suddenly going like, this is a lot better than I thought it was. You know, until yesterday, I was convinced that the Unity is the only engine in which I can make my to-do game because I'm not going to do a 2D game in Unreal. Game Maker is too far behind. Godot is, everybody's saying that it's a hobby engine and you can't do anything serious with it, so I'm not going to look at that. And these people, all of a sudden, overnight, started really looking at Godot and really, really looking at Godot and suddenly going like, hang on, I can make my game in this engine. And those are the people who are either going to go through with the switch that they started in the last 10 days, or they're going to say, and that's all the messages that have been in the media, who are simply going to say irrevocably, I'm finishing my game and I'm moving over. So Unity's really shot themselves in the foot, not just by making themselves unpopular, but by waking a lot of people up to the fact that there is this other option, that there is this other game engine that is free, and that is actually good enough to make the games in. That is the thing that I find the most interesting of what they've done. Whether people will switch over, in the long term, or whether it's only a few people, it's, time will tell. But I do think that a lot of people who never considered Godot or never took Godot seriously are now taking Godot seriously and finding out that Godot is actually a realistic option for them. And in that way, Unity only has themselves to blame that they that they show people that there is actually another option. And that's of course the really weird thing for Unity as well, is even though that they've now backpedaled, they've lost all the trust. People are, going to be very hesitant and very nervous for a long time, wondering when's Unity going to make the next stupid mistake. Unless Unity tomorrow decides to get rid of the decision makers who were behind this, and make a really serious change and really communicate to the industry, like, yes, we really messed up and we want people to lead this company who are not going to mess up like this again. Then there might be a larger chance for people to, give them another chance. I don't know. Time will tell, I guess. Because one thing that I do agree with a lot of people is, Unity itself as an engine is a good piece of software. There's a lot of people who are making really good games with Unity. So I don't want Unity to go. I don't want it to die. I believe in competition. I believe in the fact that the more players there are in the market, the healthier it is for everybody. Because I don't believe in an engine that can do everything. You need engines that have their strengths, and that are, where other engines have strengths in other areas. And that's good because, then you have choice and you can choose the engine that fits your style, your way of programming, the type of game that you want to make. You choose the engine that fits that. And for some people that's Godot, and for other people that's Unity, and for other people that's Unreal. For some people that's still Game Maker, or Default, or whatever other engine that's on the market right now. So let's catch up. Yeah, that terms of servicing is so ridiculous. Yeah, George, that's the problem that they have, right? They did it before, they can do it again, and unless they really clean house, people are always going to be worried that they're going to do something else because they still have a leadership that is willing to make decisions. That's the way that I look at it, right? Is we have a leadership here at Unity who looked at the numbers and said, oh, this is going to make 90% of our customer base happy, or, they're not going to mind. And then we have 10% of our customer base that are going to cause a fuss and maybe leave. Well, we can lose that 10% if that 90% is going to bring in the bucks that we need to survive. that's a very unhealthy attitude. You know, you do not want to make a change to your pricing structure that is going to alienate such a large percentage of your user base, especially in game development where we all back each other. You know, that's the thing I think that this whole fiasco showed most is even though we're all competitors, you know, even though we're all making games that are competing with other games, we want all games to succeed because the more games that succeed, the more people will buy more games. The games are not something like I buy a game and then I don't buy any other games anymore. You know, it's something that is a market that's basically always growing. On there's always a need for another game to be made and another game to be played. So we're we really have each other's backs in this industry. And while there are some toxic people, and um, you know that's unfortunately humanity, I don't think that they realize that the game dev industry would basically back each other to this level and because there's so many people who stood up to Unity who themselves wouldn't be affected. You know, you um, if you have a game that you sell for 50 $60 a piece or even $30 a piece, you know, what are you going to care if you lose 20 cents on an install? Like, you know, even if someone installs your game times, then you know you've lost $1 out of your $30. um, but they know that they're not the only customers and they're not the only part of the game industry. They know that there are developers out there who are up and coming who will sell their game for $10. And then you sell your $10 game and you're part of some discounts time, you sell the game for $2. Well, then all of a sudden 20 cents is a big deal. So yeah, it's a weird situation. Oh, I can scroll back heaps now. Handcuff themselves with yeah. Well, you know the license agreement if they watertight and they actually make it, you know, put things in there that hold themselves to account, that might help. Well, that's the big thing, Stefan. The real damage, like you said, the real damage isn't going to be seen until a year, 2 years, maybe 3 years from now, when all the developers who really got shocked by this and who are really over Unity, but who do not have the choice to switch right now because they are so far down the development cycle of their game that they are now going to complete their game in Unity because they know that okay, we might not make the money that we're expecting, but we'll survive with the revenue sharing that we now need to do. But we're not going to make our next game in Unity. We're going to make our next game in something else. And what I find really interesting there, of course, is that some of those people are going to be choosing Godot, but there are also plenty who are going to Unreal, because it's not about the amount of money. It's about how this was introduced and how it was communicated. If I honestly believe if Unity up front would have said, guys, we're just going to do 2.5% revenue share, and it's going to come into effect on the 1st of January, and we're going to do it for any game that's produced from now on going forward, people would have said, okay, that sucks, but we understand. We want the engine to survive. The engine needs to be funded. Sure, we'll go along with that. The fact that they didn't, that they really screwed it up, is indeed going to mean that as soon as people finish their games, they're going to look at the other engines again. They're going to be doing research on the other engines throughout those 2 years. They're going to see Godot grow. They're going to see that Unreal stays a hopefully a strong option in the market. So yeah, in 2 years' time, they're going to be ready and prepared to switch. So unless Unity does something amazing to convince those people who are already decided now that they're going to leave, that they rebuild the trust with those people. They do have a year or two to rebuild that, I guess, but I don't see them doing it. Well, indeed, Ismer, it's just such a shame, and like I said, it's not about whether you like Unity or not, or whether you think it's a great engine or not. It's an engine that's helped a lot of people build the games that they want to get build, and that's a good thing for the industry. So I don't want any engine to undergo something like what Unity is undergoing right now, because even though we're a quote unquote competitor, it's bad for the industry. It also is bad for us, because what if this would have if they would have just gone through with this? You look at all the Unity developers who did not have the chance to switch because they were part, in that development cycle at that point where switching engines would have been such a big cost that there's no point in finishing the game. How much value that has been created in building these games would have been lost by people suddenly saying, what sort of effect would that have had on um, all the publishers who have invested into studios to make their games, when then they come back and say, sorry, but we can't finish it in Unity because we won't be able to make the money that we need to recuperate our costs. We can't complete the game. We can't port the game because that's also too expensive. We're just gonna, sorry, we're just gonna throw our hands up and quit. If that's the exodus, and that's 10% of the Unity market that has that sort of exodus, that will be felt through the whole industry. So yeah, it's not just about whether you like the engine or not, or whether you agree with the engine or not. It's a bigger picture problem. Yeah, I think I've had Unity installed for about an hour on my computer at some point as well, because I wanted to check out something XR, and then I got distracted and I never had time to do it, and I deleted it again. um, and then again, I've got friends who use Unity and who've done successful things with Unity, and I've helped them out with shader issues and stuff like that. So it's not like it's a bad engine or anything. It's just the company makes weird choices. They're saying that they're going to port whip games to Godot, some of which are sequels to big titles. This will boost the momentum. Yeah, absolutely. And again, Stefan, it's not something that we're going to see the results of immediately, but I honestly believe even people who right now are very far along in their game, and decide to finish their game in Unity, are going to start side projects on Godot. They're going to do that to build up their experience. They're going to do that to get a head start on, because they realize that they can't take the code that they've written for their current game and take that over to episode 2 of their game, or whatever. They have a whole bunch of work that they have to redo, and might as well get that started, so that by the time that you release your game, you have built that foundation with which you can switch to another engine. I think porting is only easy to very small. Yeah, and even small studios or indies, it's and especially for me, keep in mind, for people like us who have been using Godot for a long time, yeah, it's not a big deal to port smaller games. Even if a game has been worked on for, like, say, a year, all the artwork can just be reused. All the assets, other sort of assets, music, 3D models, all that stuff can be reused. It's only the game logic that you have to redo. But even with the game logic, you've already thought it all out. You have it working in Unity. So you just need to learn Godot to a point that you know what the best way is to create that same logic in Godot, and then just build it. It takes much more time and effort to do it the first time around than to redo something. So a game that took you a year to build might take you 2 or 3 months to port. Well, that's doable. A game that took you 3 years to build, yeah, now you're suddenly looking at a year or something of extra work going through that whole code base and redoing that all. So And again, it all depends on how experienced you are, right? If you're a Unity programmer, you have never worked in Godot, you're going to spend a month or two doing the wrong thing first. We've seen plenty of examples of that on the internet of people, you know, doing something the way that they're used to in Unity. And sometimes that's the right thing because games are games, so a lot of things work the same. But sometimes it's the wrong thing, and they run into a part of Godot that might not work very well because we don't work that way. We work a different way, and we have other components that actually result in the same goal, and those components are, optimized and improved because we all use them, and that's where all the attention has gone in improving those. Possibly Paper Martin. I have no idea where that boundary lies. But that might have been part of their decision that they sort of went like, oh, most of our users are hobbyists anyway. We're not really making money of those guys, so why would we care what happens to them? Don't know if that's what happened, but Ismer, absolutely. When I look, and that's also why I really am unhappy of a certain subgroup of people, both on the Godot side and on the Unity side, probably on other engine sides as well, who have gone online and who have shown to be incredibly judgmental and harsh towards the people in the Unity community who are suffering under this. And I don't believe in that. I don't believe that Unity developers, whether they choose the Switch or whether not, whether they choose Godot or whether they choose Unreal or whether they stay with Unity, I see them as my colleagues. I want them to succeed because the more game developers succeed, the stronger our industry is and the stronger we are. We really are stronger together than apart. And that also means that there is more than enough room for multiple engines. And it really is a shame that we do have a subgroup of people who are very judgmental when someone doesn't choose their engine or agrees that they shouldn't be with Unity because Unity is evil. How dare you still be with Unity? That's bullshit. People need to choose the tool that's best for them. And I see everybody who's in game dev as someone who goes through the same struggles that I do. So respect people's choices in the end, even if you don't agree with them. VS Code and GitHub. I wonder how. I don't know. I do use VS Code. I do like it. I do believe that Microsoft is likely going to keep supporting the open source community with tools that are free to use. GitHub especially, if they mess GitHub up, they're going to get such a PR disaster from here to Tokyo. I don't see them doing that. Plus that, it really does look like it helps them have that platform in the sense of, there's a lot of goodwill that they create with that. And that's much more valuable than, money that they could be making by charging someone to host a open source repo that actually doesn't make money. That's just doesn't make any sense. So I'm not too worried about that. Plus that, and this goes more for GitHub than for VS Code, is because in the end GitHub is a management shell around Git, and Git itself is open source and free. If tomorrow GitHub says to me like, "Hey, Bas, you've got a repo Bastion, or you're not an official open source, a non-profit like the Godot Foundation. You're just a lonely developer. We're gonna make you pay $10 a month to host your repos." All right, then I'll move all my Git repos to another service. I don't care. I'll start, I'll open up an Atlassian account, or I'll open up a GitLab account or something like that, or I'll host my own GitLab server or something like that. It's even though that would cost the same as paying Microsoft $10 a month, just to spite them, I'd do that. So, and I don't see that happening. I'm not too worried about that. Um, Lawrence, rendering effects is a new system that we're hoping to merge before Future Freeze, and also is going to be in 4.3, but it should be added to 4.2 if everything goes right. That provides you with a number of callbacks during the render process, so that you can add additional render stages. And we're mainly using it for doing post effects, so that you can write your own post shaders, and we'll get once I catch up with with everything on the chat. We'll continue where we left off, and you'll see pretty quickly what it does once this starts working. We're pretty close to it doing something on screen. Unity wasn't paying attention to the amount of hobbyists using their engine when calculating. Yeah, it could be that they weren't paying attention, or they didn't care, or and again, that's the thing that I need to be very careful with. I'm also a little bit judgmental in this case. That I'm sort of going like, this how could they not have seen this? Well, maybe they really didn't. It's very possible that they really underestimated what was going to happen. But it's also possible that they didn't, and that they accepted that a certain part of their clientele would simply leave them and cause a lot of fuss. What I do absolutely believe is that they never realized how big the opposition would be. I don't think they would have that they at all expected that so many developers would join hands together and give such a public pushback to them, and not just developers in the Unity community globally, Unreal developers, new Godot developers. Um, we all stood together and went like, okay, let's help each other out. We help each other out by letting Unity know, how destructive this pricing system is. How yeah, sure, there's lots of games that wouldn't have felt any pain. It's about the people who are already struggling and who are already in a very competitive low margin part of our industry, who you're basically killing off. And the fact that all studios, or a large portion of studios, sort of went like, this is not right. Even if it doesn't affect us, this is not right. Unity, change this, or we're not going to trust you anymore. I don't think they saw that one coming. Well, Patrick, that's part of it as well. How big Unity has become in the educational institutions, because that is the logical choice to teach your game dev classes in, because that gives people who finish the game dev classes the highest chance of finding employment. Yeah, I think those are going to start looking at alternatives more. Although, even before this, one thing that really amazes me, and I see this a little bit more closer than most, because because I get involved with the leadership in this. The number of educational institutions that seek us out, that want to use Godot in an educational environment, to teach kids programming, to teach game development classes, or just programming classes. That's growing like crazy. And I think that has a lot to do with how easy Godot is for a beginner to use. You can what is really nice for Godot, I think, in that environment is, with just a few lines of code, you can do something. You don't have a whole bunch of boilerplate to go through first, before you can do something interesting. So I think that is a very appealing part of Godot. And I think the other thing, and this is This is, I think, also where there is a duality in our industry for some people who really love this and other people who can't stand it. Is how visual Godot is. There's so much that you can do purely by putting the right notes together and linking things up and all that sort of stuff, and then writing 4 lines of code and something works. While in many other engines, it's like you have to code that, because that's logic. Why are you putting blocks together to create logic? That doesn't make sense unless you're doing blueprints, but that's a whole different story. In Godot, there's so much indirect logic in the way that you organize your scenes. You look at how physics work. With all physics area objects automatically doing stuff and interacting with each other, and then the end result of that's the only thing that you need to react on. It's that sort of stuff. Yeah, Stefan, exactly like I was saying. The industry needs the diversity. It doesn't help anybody for an engine to fall over, especially not an engine that is so widely used. It would negatively affect us all. So an engine that slowly becomes irrelevant and people start slowly to move to another engine, that's healthy to some extent. If an engine doesn't innovate or doesn't want to change and adjust itself to the times, then they're going to slowly die. But then that's not a disruptive event. That is just something that where people slowly leave for better options, and the competition will move to something else. But something like what happened now, where you have one of the top engines in the world all of a sudden making a choice that would create this huge shift in the industry and potentially make Unity unsurvivable. Yeah, that's. eh, I'm glad that they backtrack. I say it that way. Sorry, I don't read Chinese or Japanese, so I can't say your name. But the person who is a Unity artist and um, is now making their first or finishing their first game at the age of 40. Well, as a fellow, well, I'm a couple of years over 40, but I'm still in my 40s. My hats off to you, sir. Very well done. And again, that is one of the things that does make Godot good. It you know I'm not gonna say that Godot is better than Unreal or Unity, and it might never be anywhere there, and I don't need it to be that. What I need Godot to be is an engine that I enjoy using and that I, with my skill set, can make a game with that I want to make. That's the only thing that is important in your choice of game engine is you have to look at your own skill set, you have to look at the needs for the game that you want to make, and you choose the game engine that fits that best. And that can be Unity, that can be Unreal, and that can be Godot. It all depends on who you are. There is no such thing as there's only one engine that's the best and everybody should be choosing that engine. It's nonsense. You know, you don't need the fastest engine or the best renderer in an engine if you're not going to be using that power anyway. And if you then choose a game engine in which it is 10 times easier to make the game that you want to make, then that is the engine you choose. I tried VS Codium Game Dev Chris, and obviously, VS Code is VS Codium plus a bunch of Microsoft things. The little bit of sauce that Microsoft adds in, uh, I found it very hard to do without. So, yeah, I tried VS Codium for a week and then went back to VS Code. Sort of like, um, that might be my escape route if Microsoft ever decides to do something with VS Code that I really can't agree with. But yeah. Um, that was a pain of my part. Yeah, I agree, Stefan. It's I don't mind a fun poke at the other game engine, and there's plenty of things that happen that I laugh about too, and that's sort of like, oh, that's stupid. Why? Uh, but that's a whole different thing to people saying like, how dare you use engine X because they're evil, or engine Y because they're this or that, or should only use Godot because Godot is open source and only open source software is good. Like, no, choose what works best for you. It's a bit. Engine is definitely being pretty. Yeah, it is. It is what it is. Unfortunately, there is a subgroup in our game dev community that doesn't seem to understand that we're all in it together, that we're all trying our hardest to do something that we love, and it's just not right to be um, to be what's the word that I'm looking for? To be toxic to each other. It doesn't make sense. Sin, you haven't missed the stream. We're about halfway through, but we have gone down a whole discussion spiral, and I am still scrolling through the messages until I get back to to the end and back to working on it. But you haven't missed everything. There's still plenty that we're going to be doing on stream. Game Dev Crystal, yeah, that's one of the reasons why I'm doing what I'm doing tonight. Is in version 1, the stuff that is currently finished and that we're hoping to get merged before the feature freeze at the end of the week. That is the low level boilerplate implementation, and in there you have to do a lot of you have to really know how the renderer works. You can get pretty far with some of the examples that I've created, and sort of copy and paste all the boilerplate code and get pretty far with what you want to do. But the next step is to build a couple of things on top of this, and that's what I'm building right now is sort of like a prototype of that, where all of a sudden we have the complexity either already built into the core, or you put it into a plugin that you can download that gives you a bunch of base classes, and you just implement things in there. So in this case, the idea is that you end up with, hey, here's a boilerplate shader that you get the moment that you add this effect, and then all you need to do is write the shader that you want to do, and you have your post effect thing. Now, the big brother of this will be hopefully something that it won't be in 4.2. There's just not enough time left before the deadline, but which I hope to add to 4.3, where you add a post effect, a material post effect to here, and it will just have a material slot, and you create a new Godot material, and it will have a new shader type that you can then use, and that probably, just like all the other shaders, it'll generate all this, and it's only this little bit in between that you then need to write yourself. And just like normal material shaders on 3D objects and 2D objects works. So that's something that I'll be doing in 4.3. And again, the whole point is that with the render effects that we've created right now, the world's your oyster. You can do some really complex things. Like I said, in the beginning of the stream, I was working just for testing stuff. I was working on a screen space reflection system. In part to test the render effect system and to really stress test it, and on the other part because I wanted to try a new technique and figure out how that works. Something that me and Clay have been talking about for the last half year to a year, that we actually want to retrofit into the screen space reflection in Godot itself. Just to see, like, hey, can I stress test it? Can you do something that complex with this? Yes, you can, as long as you know what you're doing. But that is not something that a normal user would want to use. So again, that was our whole plan, is we have this render effect system that is very low level and really targeted at the informed users in Godot. The less informed users can get quite far with copy paste someone's code and just put the things in there that they want. But the idea for later is to add a few layers on top of this to make it easier. I think where you have to get involved in something by choosing one option over the other. Kind of tribalism is going to appear, and I think mostly comes from insecurities. It does, Pan. I think it also comes to from a sense of belonging that people have. You know, it's kind of, unfortunately, it's kind of sort of human nature, where you know we like to be part of communities, and for some reason we then become very protective of that community. And to some people, that suddenly becomes like, if you don't want to be part of our community, there must be something wrong with you, and therefore I am going to tell you that you're a bad person because you don't agree with us and you don't want to be a part of our community. And that's an unfortunate part of humanity. Um, and I think that it might even be overrepresented in our business for the simple fact that, at least when you look at the programmers in our business, maybe a little bit less for artists, because programming is a very logical line of work. Um, we have the misconception that if our logic that we apply gives us a certain outcome, then that must be the only outcome that is true, because that's logic, right? You know, if 1 + 1 is 2, it can't be 3. Therefore, if an open source engine made by volunteers gives you the best engine, then any engine that is not open source and not made by volunteers can't possibly be the best engine. That's very faulty logic. But it is logic nonetheless. So people have a problem that if they come to a conclusion and other people don't agree with that conclusion, then the other person must be wrong. And that is really a part of humanity that you need to dispel and sort of go like, no, you know, there are multiple roads that lead to Rome. There are multiple paths that we can take. Just because this engine is the right choice for you doesn't mean that it's the right choice for someone else. So don't give someone else a hard time because they made a different choice than you did. And I do agree with you that insecurities do play a big role in that. You know, the fact that you are not sure that you can reach the finish line with your game, if someone else makes a different choice than you do, you start to go like, did I make the right choice? Yeah, probably you did. If that's the right choice for you, it doesn't mean that that's the right choice for the other guy. So his choice might not be the right for you. So don't be insecure about it and don't be mad about it. Just accept that you made a different choice. George, there's the yes, no, I don't know. Um, I've seen some really bad things in my life when it comes to companies fattening themselves up to make a big splash on the market, and that never ends well. Um, you know, we had I don't know how many of you guys are old enough to remember the big telecom bubble that burst in the early 2000s, but that was also largely created by that. You know, the skies was the limit for investors to invest in telcos, and there were some telcos that were really doing good work, and then there were a lot of telcos that were just bloated companies that really didn't have any value in them, and all they did was make it look good in the books and get people to invest in them when they went public. And then, you know, the people that owned it at that point in time became wealthy, and the people who bought the stocks, they lost it. So that's unfortunately part of the world. However, the fact that there are companies like that out there doesn't mean that they're all bad. There are plenty of morally run businesses out there that you know that want to make money the right way. So just because someone wants to be commercially successful does not automatically mean that they will do evil things, but some of them do. So I don't know what Unity's motivation there was, um, whether they just got themselves into a hard place and thought that this was a way out, or Because it is true, Unity is losing money. They have to get their revenue up if they want to survive. So, yeah, the big question is, did they just make a dumb choice and didn't think it through, or was there something more in there? I think there's a lot of people who are thinking right now that they wished that they ran into Godot earlier. And as I was saying in the beginning of the stream, that's Unity's biggest mistake in this is there are a lot of people who have now discovered Godot, or who already knew about Godot but didn't have a good impression of it because they've never tried it. The internet is not always friendly to us. There are people who are spreading the most ridiculous conspiracy theories about us and saying the weirdest things about what Godot can't and can do. And those people, instead of seeing a YouTube video about someone complaining about something or making a very short or reading Reddit or whatever, and sort of going like, oh, that sounds like that Godot thing sounds bad, and it sounds like it's run by a bunch of idiots, so I'm not even going to look at it. Now they were forced to look at us, and most of them are probably going like, these guys are actually pretty friendly. They're very inviting. Everybody's helping out. I've tried the engine, and actually I can do much more with it than I expected. Some people actually even turning around and saying like, geez, in 1 week of experimenting with Godot, I've done more than a month in Unity. There are those, and that doesn't mean that it goes for everybody. But there are certain games that Godot, in my eyes, is a better fit for than Unity, and people who make that sort of games, they are now discovering that Godot is actually a very viable choice. And they wouldn't have done that if Unity hadn't made the decision that they made. So yeah, thanks Unity for focus on making people try that. Pretty cool. Is there a example with mesh rendering and rendering effects, or is it just compute shaders? I was working on a example that did a raster pass, because you can definitely do that. The only problem that you have is you can obviously create through the rendering device a vertex buffer and index buffer and render a mesh, but you would be building that bit yourself. We are planning to make the mesh data that you have, for meshes that you have created, so that if you have a mesh resource, and Godot will create the buffers for that mesh resource, that through the mesh resource you can access those buffers and use them. But what you can't do in rendering effects is initiate Godot's rendering pipeline itself. To reproduce that in rendering effects would be a massive job. So you can't just suddenly say like, hey, I want to insert a step in here, and I am just going to render this object with the whole rendering pipeline of Godot, but with small changes in the shader. That's something that you can't do. So yeah, there's there are some limitations there. Engine X. Okay. Yeah, no, Engine X and Engine. Yeah, okay. My fault for misspeaking that. Not to say that Engine X isn't a bad thing. It's actually a pretty decent web server, but yeah. Can't someone just have publicly traded company sell some when it's really high and overpriced? Make a stupid decision on purpose? Make it yeah, well, again, Georgie, there are unfortunately examples out there of stock traded companies that try to manipulate their stock like crazy. And while we do have laws against that, depending on which country you are, they aren't always that strict and good. Again, that doesn't mean that Unity did that, right? That's the thing, is from the outside it might look that way, and in the inside it might be that way. We don't know. We there's no way for us to knowing unless you become a Unity employee and you become friends with what's his name, John Rittinger or something. I can't even remember what his last name is. Then you might find out if they really just weren't smart and didn't see this coming and made the decision because they felt they didn't have any other choice, or whether they really they really played a bad game and risked a whole industry just to enrich themselves. It's You won't know that unless you know these people. So we can have our opinions and we can have our conspiracies and we can have our what you call it, our theories, but until someone does a proper investigation in that and comes out with it, we won't know. And I'm not going to make a judgment on that. I love speculation. I do think about it. Like, okay, uh, how much did they do this on purpose, and just were called out by how big the reaction was, and how much how much did what because again for Unity to survive, they need to have money in order to build the game engine. So it is absolutely possible that they just didn't see a better way to do this, and that they hoped that the fallout wouldn't be bad and went ahead because they didn't see another option. It is possible. And again, that's also with the decision that they made now. It might not be a decision that's good enough to guarantee the survival of the company. If they are in that much trouble that they had to make the decision that they did 10 days ago. Yeah, I don't hope so, but it's possible. There's so many lines of thought that you can have in this. Who knows what's true? Paper Martin, I don't know enough about Unity in that respect. I've heard incredibly mixed things about how good, bad, and ugly Unity actually is, including from friends of mine who have worked on the source code. And my own little bit of experience helping some friends who were building games with Unity. There's lots of people who love certain parts of Unity, and I am absolutely convinced that they are really good. But whether they are a fit for Godot, I don't know. Godot has, and this is one of the problems that we do have in this industry. Well, it's not a problem actually. It again boils down to that choice. Who are you? What sort of engine do you want to choose for? I don't believe in the concept of one engine for everybody. And what's really important is that Godot has a very different philosophy to building a game engine than an Unreal has or a Unity has. We have a real focus on making this engine as easy to use as possible. We have a very generalistic view. So while that means that you can make a large group of different games, a large spectrum of different games. Don't make noise, you. A large spectrum of different games, and that you can make them without needing to be a godlike programmer. There's also a lower ceiling to how high you can take things. I said that in my last stream. And this is my belief. I don't know how true it is, but when I look at Unreal, I see an engine that's very specialized to a much narrower band of games that you could make with them, but you can make them way better than Godot will ever be able to offer. And that's simply because they specialize in those types of games. And Unity is kind of in the middle. They also, just like us, try to be a very generic engine, but they were more than willing to say we're an engine only for people who learn and who need to have a certain skill set. So, yeah, John Riccitelio, indeed. So yeah, I don't know. I don't know enough about the higher level rendering API that Unity has to know whether something like that, or something in the same line of thought is a good fit for Godot. I don't know. Who knows? Um, where am I? Game that Chris, yeah, might be illegal, but it doesn't stop everybody, unfortunately. Um, it's more Occam's razor. I need to look up what Occam's razor means. I've heard that lots of times, and I don't actually can place that. Shavir, how you going? Long time. It's pretty good. I'm trying to finally get to the end of the messages. Hi, bro. Please make Roblox bug free. I don't think Roblox is made in Godot, so I'm not sure if I can be of much help there. Um, some crazy questions about how to do certain things, but I understand that they are new. Um, you mean about new people into the Godot community coming from Unity? Yeah, that's understandable. You know that John Unity. How's your channel traffic in the past 2 weeks? I haven't checked the growth in the last 2 or 3 days, but when I last checked, I was up 200 subscribers. While normally I get about 20 to 30 subscribers a month. So, yeah. My channel is growing, and that's pretty cool. And especially considering that I, at the moment, don't have a whole lot of time to actually prepare videos, which is something that I want to get back into. Um, but yeah, it's very time consuming to make videos, and right now with the amount of workload that we have in making Godot a better product, it's been a bit of a struggle. But that's why I like doing streams, and right now I'm doing a little bit more than I really want to. But I kind of want to go back to a weekly stream at some point, and maybe this might be the push I needed to do that again. Because the nice thing that I find about streams is, I do them and then I turn the camera off and I'm done. Um, and I like interacting with you guys live. I do have to say that is a lot of fun. Um, another way you can look at it is that you see your company turning into a bubble that may burst. So yeah, it's possible. And again, Georgie, we don't know. We can only speculate, and we have to be a little bit careful with speculation because, we can accuse Unity of things that are very insensitive, and I catch myself doing that from time to time when I'm just musing about things and sort of going like, maybe they did it for this reason, or maybe they did that for that reason, and I'm sort of going, well, maybe they are that evil, but maybe they're not. I don't know them personally. We're focused on Unity right now, but I have the same problem, for instance, with Meta. Right? There's so much negativity about what Facebook is and what Mark Zuckerberg is, and maybe some of that is true. When you look at the social network movie, you get a really bad view of these guys. But the reality, from my point, is from where I'm sitting, is I've never met Mark, so I got no idea if he's a nice guy or not. But I have met a lot of people who work for Oculus, what now is Meta Reality Labs, and I can only say good things about those guys. The people that we've dealt with, the people that have helped Godot, they're really good people. So that doesn't line up with some of the public image that Facebook has. Now that could be because these guys started at Oculus and built a really nice little company, and that's still, even though it's not part of Meta, that's still, you know, its own thing. Or it could mean that Facebook really isn't that bad as everybody makes it out to be, but they made some bad choices in the past, or it's just a result of the market conditions that they're in, and the business that they run. It's very hard and very unjust sometimes to make too harsh a judgment on how these companies are run, and whether they truly have evil leaders at the top who just want to milk people and really don't care, or people who actually are trying to make a good product. And unfortunately, there are always people who try to abuse that product, or who do something with it, or simply make mistakes. You know, there are also some things that are just mistakes, and you can't really do anything about it. But yeah, it doesn't mean that we can't be critical about these companies, but you know, everybody's just trying to make a living. So yeah, oh yeah, the simplest thing is the most plausible thing. Yeah, I know that that concept. Um, yeah, Paper Martin. That's the weird thing is I am someone who doesn't really want to judge code simply by how pretty or how ugly it is. Sometimes to make something work really, really well, you have to do some ugly things. When I look at Godot source code, and it's one of the reasons why I chose to use Godot for my VR experiments, and even eventually rolled into my role at Godot, is because for the most part, Godot source code is really well structured. There's a couple of old parts in there that are a bit rockety and that we're very hard at work in polishing up. And there are some things that are structured in a way that I personally wouldn't, or no, don't like, but where the more I learn about the why, that I sort of go like, all right, I get the why. Sometimes you can't. And when I talk to friends of mine who work at AAA studios, and I talk to them about these things, and especially when I talk to people who have worked um, on like really high selling AAA titles that have custom built engines, prettiness goes out the door because prettiness isn't fast. So they will write the code that is needed to make something um, as fast as possible. And in these days, we've kind of been able to sort of pull that back because computers have become much faster, compilers have become much smarter. Um, but I remember talking to people, 10 years ago, who were writing code where they did the compiler optimizations in code, where a good example is, in a shader, you you very often see that, okay, I'm loading a value from a texture and then I'm using it and then I'm assigning it and then I'm done. And in reality, that's very inefficient. What you're much better off doing is to put the texture load all the way to the top, and then because that's going to load the texture, and then that won't be there right away. It has to do something on a parallel thread to get that, or however it works on the GPU inside, to get that texture value. And in the meanwhile, it can do a whole bunch of other things, and then so that code will becomes a complete mess. Now, luckily today we don't have to worry about that anymore because the shader compiler does that for us. But I remember in the day that I can't even remember who that was that I was talking about that with, but who was saying that um, when we had the early GPUs, and the early GPUs couldn't do that much yet. What they were doing is they were exactly timing how long things took to then even do part of the code back on the CPU, because they knew that by the time that the CPU code was done, the GPU code was done, and they could sync it back up and throw it the other way, and suddenly they won a whole bunch of time. That's not pretty code. You see that code, you have no idea what's going on unless you're the one who wrote that. But that is how you got the fastest code. So I don't believe in this. It has to be pretty. That can be a goal, And I think actually for Godot, it is more of a Godot that because of the type of people that we want to invite into working on Godot, the more clear the code is, the more stable the code is, the easier it is to onboard more people to help on a open source project. And we then accept that we might be 5 or 10% slower than the competition because the pros, the fact that we can get more people involved and have more people read the code and review code and stuff like that is far more important than getting that last 10% of performance. So following you since just as Godot racing game. Um, yeah, I have fond memories on building all the early stuff, and I need to get back to making some more videos like that. It was all it was bad performance wise. Yeah, that yeah. Again, I I can't comment on how good, bad, or ugly Unity code, the internal code of Unity's renderer is. I can only muse about it and say, well, it could be bad, it could be good, it could be the best that it could be under the constraints that some people work with. Again, this is the big thing that Godot also runs into, and I think where Godot and Unity does have overlap, the fact that we're both trying to be general purpose engines, and the one Achilles heel that a general purpose engine has is we can't optimize for one vertical market. So um, the optimizations for, say, an open world game can be completely different to the optimizations for, um, a high intensity first person shooter game. So we need to find some sort of middle ground there. And that middle ground, when someone who and someone from a AAA studio who has made purpose built engines goes and looks at our code, can immediately say, why do you do that? That's not fast enough. To which we say is, yeah, but we also have people who make this sort of games, and what you're suggesting to make that fast doesn't work for those games. What do you suggest that we do? That we forget about those people? um, that is always the trade-off that we are working with. Is very often performance is gained by narrowing your feature set, by zooming in on, we're just going to make something that works in this area and works really well in this area, and that's in other areas it would be slow. Then we don't care, we're optimizing for this specific goal. Let's see. My code is the most beautiful code that you will ever lay your eyes on, but it just doesn't compile. Oh yeah, well, um, let's see, anything else? Yeah, beauty is in the eye of the beholder. That's absolutely true. And Georgie, obviously one thing that, because I've always been a believer in writing clean code. That's something that I pride myself in. That as I try to write my code in a way that, and I guess that's also in the habit of making videos, is when I'm writing my code, I'm a big fan of the rubby ducky approach, where and I think that's why I like doing streams, and that's why I like doing videos, is because I always write my code with the idea, okay, I've got someone sitting next to me who I'm explaining what I'm writing. And if I write really crappy code, and that's even when I was, what did I just do? I Thank you. You know, when I was looking at that Mutex code thing, where I was working in my head like, this doesn't look right because I can't explain why I'm doing this, so there must be something that I'm doing wrong. Um, and you know, at some point I sort of said, okay, let's just do this and try if it's the right thing. But for a lot of things, I'm sort of going like, hey, if my code doesn't look readable, I'm not doing a good enough job. But that's my personal style of programming. When I started doing demo scene coding, where you had to get the last bit of performance out, um, that often clashed with what we were doing. Um, Although I still try to write as clean as possible code. Nowadays, I don't have that worry anymore because I believe in the compilers, and that's more for the C++ code that I write than GDScript. But I believe in the ability of compilers to apply all the knowledge that has been gained over the last 30 years in how fast code is made. And the optimizers in compilers are quite amazing at doing that sort of thing. To a point that, you know, there is probably only a handful of programmers that are to the level that they can do it better than a code optimizer can. Um, so yeah, I'm a sticker for trying to make my code as readable as possible. Stefan, I don't believe in that. I agree with you that if I do this, I say this code locks a mutex because we need to safeguard accessing this memory. That's a stupid comment. That's a worthless comment. If I cannot understand that those next 4 lines are doing exactly that, then then I'm writing really bad code. Or the person who's reading my code doesn't know anything about threading. That's the other option, of course. And that could be my only reason why I would put a comment like this in here. If I know my audience might not be aware of what certain things do, then I do think that's a valid reason to add that sort of comments to your code. And to some extent, I do that more because obviously I make training videos and stuff like that, and I'll add more comments there than really are needed, just because, you know, I'm trying to teach someone, and I'm assuming that the person that's reading my code is new to this and may not understand what the code is doing. But a sufficiently experienced coder should not need this comment to know what these 4 lines of code do. However, that's a very important comment, where I am communicating to the person who is reading my code. You know, you can assume that all the code that you find behind here is run from within the rendering server thread, and therefore, you know, it's safe to add stuff there that is, you know, that you expect to run on the rendering thread. So it's things like that that are very important. The other one is, for instance, the comments that I made over here, where I'm saying, well, this is the point where I am freeing this code. I don't have to explain that this is freeing a shader, but I do have to explain, why am I doing it there? Because that's a weird place to do it. Well, in this case, because we don't have a better place to do it because of this disjoint between the main thread and the render thread. So there are definitely a lot of things that I believe that add context to the code that are worth to put in comments. So I do believe in properly commented out or code that has proper comments in there. But they should not be explaining what the lines of code are doing that are following. They should add additional information that explains why you're doing something. And that's what's very often missing in lots of code is, you know, why am I doing this? Because you can, you know, I can understand what it's doing, but if I don't understand why, I can't see if the code is actually doing the right thing. Oh, absolutely. You know, I'm absolutely understanding that that it's an easy throw off remark to make and say, you know, because in general, I do agree with the statement. You know, like I said, there's so much code that I've read over the years that is filled with this sort of stuff. Or you know, one of my favorite, and I'm pretty sure that there's people you know listening in right now who are sort of going, "No, Baz, you're wrong." Um, I hate variable names that tell you something about variables. So um, this is, I think, a Microsoft standard that was for years, where um, you would add a prefix to your variable name that indicated whether it was a pointer, what type of it, type of thing, whether it was a character or an integer or a float or whatever, and then you gave it the name. And I'm sort of going like, why would you do that? The name should tell you know the name should be descriptive, you know, and even there, you know, there's names in that come up for standard that are too broad. But I find it very important that variables are named to be something that tells you everything that you need to know, or as much as possible as you need to know about what that variable will contain. I don't care that this is a string because that's what I have, you know, auto completion for, and that is what I have, you know, typing for that is being checked while I write code. Um, Plus that, if I see a variable name called shader code, I know that's not an integer. I know that's not a boolean. I know that that's going to be a string that has data in it. So um, again, it's but for other people, you know, and I can also understand in older days um, when editors and EDAs didn't help you so much, that might have been valid information to have in your variable names. Although I do always do the p underscore for parameters, but you know that's an old habit that I that never dies. Yeah, indeed. One I plus equals one is add one to I. Well, if you don't know that that line of code means that it's doing that, you might not be writing your game in the right language, or you might not be a programmer. One of the okay. Yeah, I think it's Hungarian notation. It could be that. But again, you know, it's some of it is also completely subjective. You know, it's whatever you like. Anyway, I think I've been talking for over an hour. I think it's about time that we do something again. So where we left off is that in theory, and now we haven't tested this yet, but in theory, when we make changes to our shader, that should result in it compiling. Now, in this case, if I well, we'll see, because it might be smart enough that it doesn't actually assign the variable until we tap out of this field. But it's also possible that as we're typing, that it will continue setting this, which will slow this down quite a bit. But we'll see what happens. I don't really want to put print statements in here to find out because it's going to be too long for that. So we're going to work on the assumption that this works. Now, again, I haven't made this a tool script yet because I don't like making a tool script too early because it causes problems. So we'll do that at the end, and then we'll see what we've done wrong. So we're compiling our shader. And actually, what I do want to do, and again, this is not going to run any code because it's not a tool script. But what I really want to do is I want to flip this around. So what we're going to do, RGB, GR. So we're going to flip the blue and red channel around so we can see that actually something happens on screen. There we go. Boom. So let's go and make that work. So the nice thing about this as well is that, and actually in this case, I would like to therefore say shader is rid And pipeline is grid. So I want to clear those both. So the nice thing about Godot is that when you Godot tracks all dependencies of objects in Vulkan or anything that that's implemented through the rendering device. So our pipeline is created from our shader, so they have a dependency. If the shader didn't become part of the pipeline, then the pipeline might stand on itself. But in this case, the shader is actually used by the pipeline. They have a link. You could actually create multiple pipelines for the same shader, and that would create dependencies to every pipeline that's created from that shader. Which means that when we delete the shader, so the moment that we say here free rid shader, then that shader is also cleaning up all the pipelines. So at this point in time, even though we still have a rid for our pipeline, that rid is now invalid. That no longer points to an actual pipeline. So that's pretty cool. The other thing which is really important to know when we are looking at our free rid command is there is logic behind the scenes that means that, or that makes sure that when we remove a shader but it's still being used because the GPU is still rendering in the background, that it will kind of queue it. It won't suddenly pull the rug from underneath itself. As long as I don't use this shader going forward, this rid is now no longer valid. All the pipelines are nicely cleaned up, but in the background, the objects, the actual Vulkan things that are created, as long as they're still in use, they are maintained until we're really done with them. So it's pretty safe, or it should be pretty safe to free it over here, at least as far as I've been told. Stefan, if you are new here, yes. The fact that we have just been chatting for an hour is because I enjoy discussing things and I enjoy engaging in with the chat. But the main purpose is for me to actually do something on stream that's interesting to watch. So yes, I do code on screen. We do have to say a lot with 200 characters. Yep. No, I actually don't have a good suggestion on a book. Now that is in part because I started with stuff like this. OpenGL Super Bible. This is an amazing book if you want to learn how to write game engines or engines, and they're probably in a. This is 4th edition. I think they're like 7th or 8th edition or whatever. And this is not even my first one because I had earlier ones. But it also has amazing examples of how shaders are written. Won't help you do anything with Godot. Godot takes care of 90% of what you learn from that book, and you never have to know that stuff. But because I have already learned all that stuff, and even though we're now doing Vulkan, lots of things I've learned in my OpenGL days apply in Vulkan as well. I'm not looking for things that are newer. I'm looking for the tutorials online that teach me how to do stuff in Vulkan when I knew how to do them in OpenGL. So for someone who's trying to learn shaders, I don't have very good recommendations, and that's a shame because I really want to, and that's even to a point when we're looking at tutorials about shaders. I did a co-op with GD Quest a couple of years ago where we did a couple of starter tutorials on YouTube, where he did the shaders for 2D and I did them then in 3D, and that sort of showed some basic approaches for shaders in Godot. And I've always wanted to make more of that, but finding an effect or finding something that you can do with a shader without it immediately becoming very complex and provide a lot of detail that you first need to explain is hard. So I'm open to suggestions. Shader toy is godsend. Amazing. And whoops. I might have already found it. Yeah, is it this one? Someone made a, I think it is this one. They made a shader toy type website, but instead of it being, generic OpenGL, it is actually GDScript shaders or Godot shaders. So I don't know. Let's have a look at the grass one. That's, I think, oh yeah, that's from GDQuest himself. Aha. So yeah, lots of examples of things. I don't know if you can run them live. I have no idea, or if you need to download them and try them in Godot. I know about this site. I've looked around it, but I've never really tried anything with it. But yeah, that's one of the sites. The other one, and I'm really ashamed to say that I don't know what the URL is, and I feel very bad about it because our very own QB is one of the main people there. But there is a Godot group or Godot website that is fully focused on creating VFX examples. And that is pretty cool. Maybe I can find that. Those are all YouTube channels. No, I can't remember. It could actually be a Reddit group. I don't know. I really don't know. I'm gonna have to ask QB one of these days what actually the location is, when because she's always talking about it, and she's always, QB, by the way, QB, what's her full name? You know what? Let's go on Twitter. Let's give QB a shout out. QB Shaw, QB Shay. There we go. If you don't know, oh, here we go. At Godot VFX Centers, does it have a? Is it just a group on Twitter? That's possible. And they've got the Discord. Anyway, if you do not know QB Shay, follow her on Twitter if you're on Twitter. Pretty sure she's also on Mastodon or something like that. She posts lots of stuff about visual effects done in Godot. Yeah, she's pretty amazing when it comes to that stuff, but she's also part of a community of people who are making all sorts of VFX effects in Godot. And yeah, she is she's doing a lot of work to get more and more VFX artists interested in Godot and show off their work and explain how things are done and stuff like that. So yeah, it could be a Discord. I know that there is Ilaria. QB Shay, Ilaria. I don't even remember her last name. I'm so bad with names. I'm so sorry, QB. When I got to know Ilaria, I only knew her by her handle. And with me, it is when I first meet people and I meet them, like on IRC or on Discord, and they just have their handle, then that's what sticks. And yeah, so I always call QB instead of Ilaria. But yeah, she's a gem. She's amazing. She does really good work. So yeah, definitely, if you haven't heard about her, go follow her on Twitter. And yeah, she shows off some amazing stuff. So very cool. Met her in Godot in Brussels some years ago. Yeah, she's just. Yeah, I haven't met her in person. It's such a shame that she wasn't at GDC, but she wanted to come, but I think there was some reason that she couldn't. So yeah. Okay, let's get back to this. So a lot of this week, actually, I'm just going to go and copy this whole thing because, as far as I am aware, this is pretty much going to do exactly the same as we did over there. We're going to be adding other things because right now there's no flexibility in this. We can only, do modifications on the color that we're reading. And that's where then the next steps are going to come in. So right now I am, well, actually, let's go through this code so we can have a look at it. And this is very similar to what we've already discussed around the sun rays demo that I did. But the first thing that we're doing is we're retrieving the size. We're grabbing internal size here. That is the size of the buffers which we do our 3D rendering in. It is possible that they get upscaled. And in there, I probably need to make some changes to this at some point. Because if you are using, what is it? That I think Dario is working on it. There's one upscaler that we're busy on that will actually be applied before we run the effects instead of after. I think that's the plan. So that would mean that in that case, we actually need to have the upscaled size. But in this case, we are getting the size that so far we're doing our 3D rendering on, even if it may be upscaled later on. In this case, we're doing a full screen effect. Now, obviously, in this case, I have hard-coded these here because they are also hard-coded here. However, one of the things that we need to do to make this work properly is we actually need to parse this. We're going to have to find this line of code in here. So that is something that we can put in here is say to get our layout line from the shader, find out our X, Y, and Z groups. So let's also say Z groups is 1, and instead of hard coding the 1 over here, we're going to put the variable in. So we're kind of preparing that. That at some point we are going to potentially, I can't really think of a situation that you would have Z groups with this. Maybe, no, I don't think for this situation, but just for completeness sake, we're going to put that in there. But right now we are hard coding on 8, and eventually we then need to parse that and actually get those values from there so that we can get the proper size. All right, Stefan, nice of you to join. Thank you for being here. I hope you enjoyed it. Patrick, yeah, I know the feeling. I've been going to these sort of events since I was a teenager, so I've kind of gotten over going to a place where you're meeting complete strangers, because when you are looking at something like going to GodotCon, especially something like GodotCon, you know that everybody there is they have the same interest as you because that's why they're there. So that's a really good thing to keep in the back of your head when you're going, if you're not used to going to events and you're doing something like this for the first time, is to realize everybody that I'm going to meet are people that I've got something in common with. And just knowing that you've got something in common with the people that you talk to can be an icebreaker, because all you need to do is talk about the thing that you've got in common, which is Godot. Most people who attend these events are more than happy to hear about what you do with Godot, what brought you to Godot. So those are all sorts of topic breakers. But I do have to say that one of the things that has really pleasantly surprised me, and maybe at GDC we had obviously some of the upper echelon of Godot members that might have made a difference. I don't know. Then again, I think on GodotCon it will be the same. Everybody's incredibly friendly. That is something that that isn't always true. I have been to user group meetings or events where you're not made to feel welcome when you're new, which just sucks. But Godot is not one of those communities. Godot, so far, my experience at least, has been that everybody's welcoming and everybody just loves to know who you are, what are you doing with Godot, what makes you come to GodotCon. It's very easy. And again, I haven't been to GodotCon itself. I'm talking about my experience with meeting lots of Godot people at GDC. But I imagine that those same people will be at GodotCon. So yeah, it's a really wonderful community that we have. So yeah, pretty happy about that. Anyway, we set up our groups here. I have a barrier in here. So basically this barrier says, wait for anything to complete before you allow any more compute shaders to run, because we are doing a compute shader here. And that's just for safety. And I believe that this, excuse me, this one has an automatic barrier at the end. Yeah, which unfortunately doesn't show the constant here, but that's the old barrier mask. So basically, after this finishes, we have another barrier, and while that would probably be a barrier that doesn't necessarily need to be an old barrier, it's probably safe to make it that way. However, one of the things that's going to be actually interesting, because we have just finished a couple of raster passes. And from memory, the tone mapping pass is also a raster pass, and we're now inserting a compute pass in between. On most GPUs, that shouldn't be a problem, but there are GPUs that don't like that. So, but I think those are mostly mobile GPUs, and this is not really suitable for mobile anyway, what we're doing. So, you know, I'm not too worried about that, but it wouldn't be too hard to rebuild this as a raster implementation as well, or make that optional, where you say, well, I want to have the choice whether I run this as a raster or whether I run this as a compute shader. Now, in this case, I prefer to use a compute shader because it makes life a lot easier, because only in a compute shader can I read from the same image that I'm writing to. If I would want to do this exact same effect as a raster shader, I would first need to make a copy of my color buffer so that I can overwrite the actual color buffer, which is wasteful. So yeah, kind of like that we can do it like this. So that's why we have barriers. The next little bit is grabbing our view count and then looping through our views. For almost everybody, the view count will be 1, and we're looping 1 because everybody just builds normal games. This is specifically for XR applications, and this also, if you always follow this approach, your effect will also work on stereo. Because on stereo we have 2 views, and you access them. So each eye that we render is a layer in our buffers. So in this case, we if this was stereo, we would first get that for our left eye, do our thing, then go for a right eye. Now, it's very important to know that there is a thing called multi-view, which we use for actually rendering geometry. And all that it does in multi-view is that it will render to the left and right eye simultaneously. So any draw call that you do is internally doubled. And when you're rendering geometry, that is very important, because you prevent a lot of state changes. You can really optimize your culling and all that sort of stuff, lighting stuff. There's a lot of overhead that you remove. But for something like this, where we're just doing a full screen effect, there is no benefit from doing this in multi-view, because it just is going to mean that our our workload might, it might be doing left and right parallel, but it's still doing the exact same amount of work. The only difference is that in one case, it's just mixing it all together, and then the other case is doing one after the other, but it's going to make the GPU just as busy, and it's going to finish just as fast. So for these sort of things, we don't need multi-view. The multi-view probably even might even make it slower, because it can make less efficient use of well, it's not really less efficient use of memory. It's less efficient use of the caches. because it is going to start swapping things out of cache more often. Let's see. Rubifix. I'm a C# dev and went to a Java conference. I feel for you, buddy. I feel for you. It doesn't matter that you were a C# developer. If there is one community, and I'm very sorry, I know I'm stereotyping. I know I shouldn't be doing this. But if there is one community that makes people feel unwelcome, then it is the Java community. And maybe it's changed. I don't know. I haven't had anything to do with the Java community for over 20 years. Um, but I have very few good things to say. I think in my life I have met one guy who did serious Java work um, that I liked, that I had a really good relationship with, and that was probably because we both liked cars, and we never talked about work. But yeah, I have some scars. Let's say it that way. Um, and it's a shame because I actually, as a language, I like Java. I don't like what they've done with it. But as a language, I kind of like Java. But yeah. The one problem that I do have is, of course, that there is obviously Android sort of brought it back in the limelight. Um, and I'm pretty sure that in the Android world, you'll probably find lots of really nice people who are good developers. At least, the handful of Android developers that I have met have all been really nice people. But I always get the feeling that they do Java out of necessity, not because they are Java programmers. I'm talking about the people who are doing JSP and that sort of stuff, or the old applets. Who remembers applets? Oh my god. Oh, Rubifix was mentioning that he had a bad experience at a Java conference, and I was musing about the fact that when I did business software in the early 2000s, I had a run-in with a lot of Java developers who were doing um, large-scale business, um, enterprise level work, and yeah. Um, I don't have a very high opinion of Java developers after that experience, and it's probably not fair of me to say. I'm sure there are plenty of really skilled and really open Java developers, but my experience has been very bad. Hey, stay at home dev, how you going, man? Nice of you to join my stream. That's really cool. For everybody else in my stream who doesn't know stay at home dev, check out his YouTube channel. He does lots of fun things, from tutorials to reviews of Godot games to his weekly Godot game overview. It's a lot of fun. So check him out. He's got some cool stuff. All right, where were we with this? So the important thing here is that we're looping through our views. Again, for most people, that doesn't matter. We're going to do a loop of one, but for our as XR guys, this is important, and it's cheap to add support in here. There's no need to change anything in your shader. It's just going to run. Now, here is where we do start to get into things that right now we're just going to keep the way that it is, but where we need to improve this thing is we're obviously going to get the color layer. Now, that's probably a given. I think every rendering effect that runs in this stage is going to be writing to the color layer and probably also reading. So that one we're always going to have, but we might need more inputs. Let's say that we want to do a motion blur implementation here. Excuse me. We will need access to our motion vector buffer. So we would need to add that in. But we don't just want to add them all in, because that will introduce overhead if we're not using those buffers. So we're not going to get that far tonight because I'm just going to get this working tonight and then leave it there most likely. But that's a good next step for this. And this is, I think, that once we go to the next step of actually making this based on a material, there's a lot of existing logic in Godot that will help us to do that. You know, we'll start using the hint system, and just like you have, you know, the color hint and the depth hint and stuff like that. You know, we can introduce a motion vector hint and say if you have that one, this is where you need to bind with this type of thing. So it'll come. Now, in line with that is obviously creating our uniform. So this is just grabbing the image handle, you know, we use rids, but indirectly that points to the image handle in Vulkan. We grab that, but we can't use that directly. We have to stuff that thing into a uniform. So in this case, we're not using samplers. We're just doing image load and image store. So we can make the uniform of type uniform type image. We're using this first binding. So for people who missed the last stream, so we're bringing the color image in. So this line is going to match up with the code that we're busy writing. The first thing that we do is we type that image. So yeah, we're still on our HDR buffer here. So this is an RGBA 16F buffer. Our uniforms are collected in sets. And the nice thing is that you can prepare a whole set with multiple bindings and then just set it. Because basically you're setting the individual sets. The more sets you have, the more overhead you have. And then within the set, you can have a single binding. So in our case, because we are updating the sets anyway, although we're getting the set from a cache, so probably when I look at some of the other ones that I have built, I tend to divide them into different sets just because it's easier to read and easier to see what the code is doing. But I think efficiency-wise, it will be likely best to combine things as in as few sets as possible. What I don't know, to be very honest, is if there are any limitations on what you can combine in a single set. I don't actually think there are limitations other than the number of bindings, and that is something that is different per GPU. But I don't know what the limits are. Probably something like 32 bindings or something like that, or might even be more. I know that the sets I think there's a limit of 4 sets. That I do know. I think you're only allowed to set 4 sets. And one of the important thing is that, and this is something that doesn't really apply for the sort of situation that we're in now, but that is very important for you know, the bigger rendering pipeline, is that if you set 0, you then have to set any set after that. So it basically, this, if I set 0 and put some data in there, let's say that I have all 4 sets here, then I need to then also supply my set 1, set 2, and set 3. But if I set, say, for instance, set 3, the last one, I don't need to do the first 3. So you'll see if you ever look at the code that's in Godot itself for the rendering engine, you'll see that we have all the information that is static, or you know, that doesn't change when rendering one frame. So our camera matrix and our projection matrix and you know, our lights information and stuff like that. All the stuff that doesn't change is in set 1. And then, for instance, I think set 2. I think set 2 only changes if the material changes. So we render everything of, you know, material 1, and then we render everything of material 2. So we just set that set at the beginning of material, you know, when we render the first object using material 1, and we set that set, and then, you know, that sort of stuff. And I don't know from memory exactly what the set breakup is, but it is very important that we have that order in the sets. Now, for these sort of things, doesn't really matter unless you want to bring in that data. That's something that I haven't done here yet, but which we have made possible. So you can bring in the uniform buffer that contains all the matrices and all the the standard information. You can actually bring that into your shader. It's already loaded to the GPU. Might as well use it. And you would you would want to set that on set 0, and then make the sets that change the most often later on. But again, in this case, because it's a single pass that we do every frame, there's not much that we gain with that. Well, I think I need to. Cool. All right. So as I was saying, we prepare our uniform, and then we prepare our set. So if we would have multiple bindings in set 0, we would be creating multiple of these uniform records, and then one with binding 0, one with binding 1, 2, 3, 4, whatever, and then we would just put them in an array here, and we would create our set. Now our set is coming from a uniform set cache. So the first time this runs, it is going to say like, hey, there it is. And the second time that it runs is going to say like, oh, I've already got it. Now that's especially important when we are doing multi-view, because we will render our left eye, and we will be creating the set with the left eye image. So that will be a unique set where the right eye will create a second set. And then we run the next frame, we go back for the first eye, and now it gets the set we've already created for the first eye out of the cache. And then the same for the second eye. The nice thing also is if we have multiple effects that are all creating a uniform set that just contain this input image, they will all share that uniform set. So instead of creating hundreds of duplicates of the same set, we just have that one set. So there's a little bit of overhead in the setup, but that's negligible in comparing the overhead in creating sets and uploading data and all that sort of stuff. So it's a nice little thing to know that there is a caching system here. And then finally we execute our compute shader. So we start our compute shader list. So everything is stored in a command list that is eventually sent to our command queue in Vulkan. We then bind the pipeline. So that was the pipeline that we created for our shader. So the shader is just a shader logic. The pipeline adds a bunch of metadata around that, and especially for raster pipelines, it has to know about what the frame buffer is, how the frame buffer is configured, and all that sort of stuff. With compute, there is no variation. You just have a pipeline; they're always created the same, as far as I'm aware. Then we assign a uniform set. So this will use that uniform set that we created and said, that's now bound to set 0. Perfect. All the bindings are automatically bound. Very good. And then, well, here we're not using any what's the word? Any push constant. And if anybody who watched my last stream, there's also a thing called push constant that you have 128 bytes of data that you can send to your shader, and you can use that for parameters and stuff like that. So we don't have that in this case. We might need to add that at some point in time. That would be pretty handy, because we would probably want to put some standard stuff in there. And then it dispatches that, and the dispatch is basically where it says go and execute your compute shader. Now, what's really important is that we are sending the number of groups that we have calculated. So in our case here, where we have a local size of 8 by 8, that means that our compute shader is going to do its work in wave groups with a size of 8 by 8. So like a little tile of 256 pixels. And what it basically does, it starts a compute shader run for every one of those pixels in our set. And I'm the pixels is a too narrow word in this case because it just depends on what sort of buffers you are using and how you're approaching things. But it's basically running 256 the compute shader 256 times in parallel. So all those pixels in that little grid are all handled all together in one go. And then it repeats that as many times as we have defined groups here. And obviously, since we have calculated our groups using the texture size, we're obviously repeating that for the whole texture. But on an 8x8 grid, so if your texture doesn't fit an exact number of tiles, then the tiles at the edge will be half filled. But it's important to know that all 256 instances are run. So for that, and this is something that we have forgotten in here, very good. And I think we need to put that into, in here, and we'll do that later. In this case, we're going to accept the overhead that it's going to load pixels that don't exist, and it's going to store pixels that don't exist, and it's just going to ignore it, but it's going to have the overhead of running it. So yeah. Ooh. Hey Rodzilla, how you going? Look goes do nuts. There goes the net. Do I translate that right? Oh, well, bye internet. Welcome. So yeah, that's a nice one to add in a minute. I wanna get to a point where what we've done here runs so that we have our base running. But I think as a last thing to add here is that we will add our push constant in here, and we will then set the size of the image in there, and we're gonna put a constraint in here. Now, one of the things is that you do have a command in GLSL that will get the size of an image here, so I don't actually have to pass that. But the thing that I don't know, thing that I actually need to find out is which is faster. Is it faster to always ask the size of the image? Does our compiler just access that data? Does it know that that's just there? Or does that mean that we're introducing overhead in our shader and it's better to pass them over as parameters? I actually don't know that. That's actually a good question. I need to find the answer to that. Anyway, in theory, this should work. So let's go and run it and see if we get any errors or if it does something that we expect. No, non-existent function spear v in base string. So now I'm going to wonder, is that something that only files can do? So, or do we need to convert it to something? That's also possible. We need to go over here, and we need to go here. So this is a load, but what does the load return? That returns a resource. So do we get something different there then? That is annoying. Because that is just a text file. So does that become a string? Let's actually just go and see if we can find get spear v. And that's an RD shader file. Okay. So can we construct an RD shader file? All right. Set bytecode, no. Spear v, that's just a version. Version list. Come on, don't tell me that there isn't a way to create an RD shader resource other than loading it from a file. That would be dumb. The rendering device API, we know that, but shader source. Oh, hold on. See also file. Source is only meant to. Okay. Maybe we need to use this. We actually have more than. Oh, that's not going to the right place, is it? All right. So let's see if that's what we need to use then. Where are we? Build shader. So we're going to say var shader source is RD shader source is RD shader source dot new shader source dot language is. I didn't know that we had a HLSL support. Ah, maybe that's for the what do you call it? Maybe that's for the DirectX one, because obviously that's on the DirectX. So that's pretty cool. Okay, Dam should have joined earlier. Exactly stuff I needed to learn right now. I created a resource with a single string for that. Okay. Well, Spear V does have HLSL support, but I don't know if you need to do special things to actually make it work, because I've never used it. Rodzilla, first of all, if you have time to watch the recording of my previous stream, I go through this beautiful thing. So have a look at this project of mine. This is a demo where there is a post process that is executed in 4 steps. And in my stream last week, I'm actually going through every step of that. I'm explaining how every one of those steps works and what the code means. I jump around a little bit at the beginning because there's a lot to cover. But this is a nice little example project that shows you how to set this up and how this works, and it's a pretty cool little experiment, and basically gives you the screenshot is horrible to see, but if you move your camera around, you start seeing the God rays come through the trees, and yeah, they look pretty cool. So that is absolutely a really good example to go through. The thing that we are working on today is, if you go onto the Godot demo project, you'll see a draft PR of mine that does this little grayscale thingy, but it also does a unfinished and still broken screen space reflection implementation as a render effect. So those are somewhat more complex things. But tonight we are building a version where, instead of loading the shader from file, we actually have the shader configured inside the effect itself. So you could create a number of post shader REs and then just copy in the file. And eventually, this is just an experiment that I want to do tonight, just to see if it all works. But if this all slowly comes together, I want to port this to the core. But instead of a shader, actually have a material there. So we'll introduce a new shader type for post effects, where that then becomes an internal template where we'll add additional entry points for whatever entries you have. Obviously, we'll have the material things, so that if you use textures and stuff like that, it'll all bring that in, and then you can just write the heart of the shader code here. So that's where I want to end with this, and I can't promise that's going to be anytime soon. Although I do hope that if this works, then I'm going to obviously make this public as anybody who wants a head start. Because the nice thing about doing it this way is you don't need to know about all the boilerplate code. You just edit the shader in here, and you can do lots of post effects without doing any of the hard stuff. So that's the goal that we have here. So we're slowly starting to debug things. Okay, so we now have a shader source. I'm guessing we need to convert our shader source to our Spear V. Okay, so see also shader source. So can we change a shader source to a SPRV? How does that work? So we have all our different. This is the other thing which is really cool. That we obviously, we're assigning the source compute right now, but you can assign the other ones. So how do we change a shader source to SPRV? Hold on. I shouldn't be here. I need to be compiled shader file in SPRV form. So that I think is already coming from there. So let's instead, oh, here we go. So can we create this? No. Change stage, no. So how do we go from a shader source? It's only meant to be used, yeah, I know that. Should not be confused with own shader source. So what Godot, yeah, no, we are doing something directly with that. String get stage source. That's only for a certain stage. There has to be a way to then do our SPRV stuff. Okay. Okay, what other options do we have? RD shader. We have a source, we have a file, we have a SPRV. Okay, what are we doing with this? So we need our SPRV. Shader creates some SPRV. Okay, let's see. Do we have something else here then? Do we have a? Oh, it doesn't jump to the right spot. That's not very nice. Do we have a? I wish this wasn't so big. Here we go. So we got our create from SPRV. All right. Shader compile SPRV from source. Ah. So, and that returns a shader SPRV. Ta-da! Okay, then we're just gonna go and use that. Where are you? Where are you? Where are we? Too many entries. So instead of a get SPRV here, what we're going to do is we're going to do rendering server dot there, and now we're gonna say shader source. Okay, was that good enough? Not found in. Did I go to the wrong one? Was that in rendering device? That wasn't rendering device, of course. So that will work. Okay. Allow cache. Yeah, that's fine. Do we really want to use the cache? Yeah, we could just do that. It does a thing. Yeah, I'm pretty happy with that. I don't know. Or do we only want to do that if we're not in the editor? That's possible. Let's just see what happens. Okay, let's see if that finally compiles. Okay, it compiles but doesn't work yet. And that's right, we have those little tick boxes there. Okay, why not? We have something in the debugger. Compile a shader. Can't create a shader from errored bytecode. Check errors in bytecode. Okay. So have we? That is because we need to go and convert this. Yeah, ASCII buffer is good enough, I think. Ooh, you can't? Is that the string after all? Does it do that internally? That could be. Okay, shaded source. String compute. No, it is a string, so it's going to do that conversion for us. All right. Can't create an error bytecode. So the other potential problem is that it's actually an error in our shader itself. So maybe we did something wrong in here. compute invocations. Vec4, color B, color G, color R, color A. That is a Vec4, so that should be good. UV, color image, color image. All right, wow. Compile. That doesn't want to work. That's so annoying. We have to go like this. So that returns, it always returns that. Bytecode compute, bytecode fragment, compiler error compute. Okay. Oops. If we have that, go and print it. Let's see if we have our error. Ooh, look at that. Invalid directive. Okay. That makes no sense. So why would it do that? Okay, for that, I am going to go and have a look here. I'm going to open up a new window. Why do you hide the bloody so far? There we go. Come on, where are your shaders? Here we go, shaders. I'm just going to have a look and see if there is a difference in the shaders here. So no, we also use the hash defined here. Although that is being parsed. That's actually a good point. We might not need the hash compute in here. Let's see if it works without that. That's very possible. Although that's also where it's. Let's see if hash version works. I also need to take hash version out. Boom. Oh, no, that was it. Ta-da! All right. It's changed the colors. It's running. Wow. Okay. No compiler error this time. But it's okay. Is that maybe a leftover error or what? No, because it's definitely doing something. Even though it's still... That makes no sense. Okay. What's RE? Let's do this. Let's make it one channel completely red. It's working. So why do we still get this? That suggests that we don't need this, which is really weird. I don't know why that is. Maybe it's because the version will trigger that it knows that it's a GLSL file. It's possible. Let's run it again. No, now it doesn't like what it's doing here. Version is required, so that made sense. Oh, that. Version 450. Let's put it back. Is there anything in here else in here that might fall over? Let's do an extra one of those. Okay. All right. Clear. Run. All right. So is the hash not needed? Is that it? No. How weird. So it says that it needs the hash version, but then it still gives us a parse error that it doesn't like the hash in there. But it does compile it. Go figure. Failed to parse. Hash invalid directory compiler. Hey, Francisco, how you going? Yeah. David, I have no idea why that is, and I also don't get why am I still getting an error here? And it says can't create shader from an errored bytecode. Check errors and stores bytecode. Yet it's running. Like what? Um, where is you bastard? Really? Really, really, really? Okay. So we have an order problem. We are actually getting our setter called twice. Once to get our default here, which we are somehow running right away. So we have a problem with when our init is called. So I guess our init is called before our really? No, our init is first. So after our init, we first set our that. And then we set that. Okay. Do we have a ready on? I don't think we have a ready on resources, do we? Okay. That's pretty insane. That's pretty dumb because how are we gonna? Because obviously we we can do this, but at least make sure that our default compiles. And I guess because it's cached, it doesn't really matter that much. But that is pretty insane that it. That is pretty insane. Okay, no more errors, but now we compile the default first, and we compile the user one. Okay. Do we have a ready? Do we have a ready? I'm not sure if ready exists because ready is a node thing, not a resource thing. Init, no ready. No, I thought so. All right, so No, we can use the debugger in this case because we're only running on one thread. But I wish we get types there. But let's see if there are. Oh, see if we get a notification that we can use. No, we don't even get notifications that we can use. I don't even have pre-delete got called. That's really interesting. Okay. Because the other thing that we could do do I want to do it like that? I might not have a choice. I might not have a choice. All right, I hate to do this, but this is the easy way to fix this. So we're just going to mark it as dirty at this point. And we're not going to worry about this. I'm going to actually take the whole make shader dirty out of there. And in our compile shader, we're going to say if not is shader dirty. And obviously we need to do a mutex unlock in this case. I always hate having two unlocks like this. I think that's always ugly, but in this case, I think that is the best way to do it. So we're going to come in our compile shader. We're going to say lock. We're going to check our dirty, and we're going to get out of there. And that means that we're going to do here if rd. Actually, yep. Okay, let's make, we're actually going to rename this check shader. And we're going to say that's going to return a bool. And in this case, we're good. All right. In this case, we're not so good. I'm going to actually change the way this looks. We're going to say shader v. Oh, actually, we need to change one more thing. This is return false. Pipeline is valid. Not return false. We're logging that now, so I don't need to keep that. Here we're going to go say true. But really, small letter bool. There we go. Instead of returning true, we're going to say pipeline dot is valid, because obviously if we failed to compile it last time, we're not. We want to make sure that that returns false because we don't have something to do. So in this case, we're going to say if rd, and that's no longer important, and our callback type is that. Oops. And then at the very end, I'm going to add in a call to check shader. Now, hopefully, and I think it works in this way, it's going to do those in order. So it's going to do that check first, then that check. And only if those both are true, then it's going to also do that check. I think that Godot is smart enough to do that. We're going to assume that that is so. So let's see if that actually works. That does. And the nice thing now is that now we only get it compiled one time. Woohoo! Sweet. Okay. So, we don't have that. I am going to keep this in here just for a minute, because now that we have something working, I'm going to change this to a tool script. And now with that working, I probably need to reload my scene. And now we have our shader working. Ta-da! Very cool. But now let's see how, at what point. Okay, so every key that we type, it's recompiling. But then again, now that we're doing it in our render thing, yeah, why not? We're gonna make this a little bit smarter. Okay, so yeah. Oh yeah, because these colors are just flipping around. I'm sort of wondering why does the ground look proper? It is pretty cool. It's immediately reacting. That's actually kind of cool. But yeah, the colors flip around. We're still using the same colors, just in a different order. Okay, so the thing that I want to do now to prevent that on every key press it goes wrong, key-driven rendering exactly, is we're going to change our dirty to a different variable. I'm going to call it update shader delay. And in this case, we're going to default that to 1. And now in here, we're going to say that is going to be, let's make that 60, 60 frames per second. So it's going to be 1 second. If engine editor is header, else 1. So we're going to delay it by 60 if we are in the editor, and else we're going to delay it by 1. Sweet. Okay, and then in here, we're simply going to say if, did I call it? Update shader delay. If update shader delay bigger than 1, we are going to say update shader delay. We're going to take 1 off. Yep. No, actually, we're going to do it if it's bigger than 0. Oh, that's wrong. No, that's wrong. What we're going to do here is first we're going to check it for 0. Okay, so if it's 0, then it's not dirty. We just exit. If it is bigger than 0, then we're going to do a countdown and just exit. So we're not going to recompile it. And in the other cases, well, if we reach 1, basically, we're going to say update and 0. So that means that now, we should have a situation. Now, probably just for safety, because we changed a tool script. Let's just reload this. and then go into here and go into here. And now we can say, let's just get all the red colors, red, red. So we can see that there was a couple of sets. And let's see, now it should have recompiled it after a second. So definitely not working. Okay. All right, let's see why not. So we're going to set it to 60. Else 1. Well, we're in the editor, so that should be 60. So let's go and do a print here. Delay. Let's see if we can see what's happening. Boom, boom. 3D. All right, well, we saw our first countdown. And our red color has turned it into black and white. So now we're going to go RGB. Okay. Okay, maybe the reason why is that it's a second is just too fast, and it will actually did it right away. So let's make that a little bit more. So I don't know. It looks like it is actually working. So let's say that we are going to give it 5 seconds or something. Oop, I didn't want to do that. I think that change actually should be pretty much direct. So because we're not introducing new variables. Okay, let's see. Let's see. G. So why are we not getting? Why is it working if I put a print in there and it's not working if I do? Okay, so now because we made a change and that just destroyed our thing again. It's very possible. Okay. All right, reload. Just in case it's caching something or whatever. Yeah, Francisco, I really enjoy working that way because I believe that that is it actually helps me think. And even when there's no camera running, I find myself having the same dialogue exactly like this in my head, where I'm trying to explain to a like I said in earlier on, it's like the term is rubber ducking. You're basically talking to a rubber duck. You're talking to a thing, and you're trying to explain your code to this third person, and it actually helps you think. And of course, in this case, the third persons are actually real. You guys, you're actually, hearing what I'm talking about. But I don't get why. Okay, if it's bigger than 1, so if it's 0, so this is truth 2 or higher, so go all the way to 1, and then it should do this. Okay. Boom. 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 Okay, and now it works. Let's do it here too. And now it works. What's so special about a print statement? Come on. There has to be something here. What's going on? Why? Why does this only work if I put a print in there? That makes no sense. Okay. This is so weird. This is so weird. Okay, save, close, open. And we can see that it doesn't recompile now. So why? Why? What is wrong here? Why are you being difficult? This is so strange. Yeah, I don't know, maybe. As if the trend what are we not seeing here? Okay. No, actually, what I want to do is this. This is gonna really spam the thing. So we are getting check shader called. Okay. I am guessing that it's got something to do with the mutex. I think it's not liking the mutex, and I think that the print is possibly upsetting that and making it work as a result. Hmm. What am I missing? What am I missing? Okay, I'm just gonna do that over there, and in this case, I'm not gonna do that. Yep. Which means that so if yep, I'll do it like that. Yeah. If that's empty, then return that. So we're going to say if it's equal to 1, we're going to go and get our stuff. If it's bigger than 1, we're going to decrease it, and then we're going to unlock it. And then our return is over here. Let's see if it has something to do with the way that we're branching, and it doesn't like that. Oh, what? Yeah, okay. Do we have an S? Is it empty or not? No, that will be nil. Actually, that's right. Is nil. Not null. Nil. Oh. Is it that? I don't know. All right. This might just need to reload now because we've been screwing around. Okay. So that is now still working. Cool. Shit. I'm stupid. I am so stupid. So Godot is smart. It doesn't refresh the screen if there is nothing to do. So if you don't have any animations, or your camera doesn't move, or you don't have anything changing in the logs, if nothing in the interface changes, Godot does not waste time in the editor by what's the word? I can't think of the word. By refreshing the screen. So our print resulted that our log needs to change, which triggers a redraw. And without the print, the screen isn't redrawing. And we don't get our thing. Oh, bloody video. That's stupid. You know what? I think I think we're overdoing it, especially for an experiment that we're doing right now. So let's go back to it being shader dirty. Actually, I'm just going to call this is dirty. I think that's nicer. Anyway. And that means that here it's going to be is dirty is true. And that means here that if is dirty is dirty is false. I actually kind of like this. It's better anyway. So if it's dirty, we're getting the shader, and else we're saying if we didn't get a shader, we get out of here. Cool. Let's go and not do that. Let's just do our computer errors. If we have errors, then we do immediately output that. And I think we do need to reload this. There we go. So let's go clear. All right. Let's see if this works. So let's go and get our color R back. There we go. So I think maybe our errors are a little bit overdone. There's a better way to do that. Actually, yeah, we'll do that differently. What we're going to do instead is do I want to do it like that? Nah. We'll think of something. I actually just going to comment it out for now. Where is it? I need to think about a good way to return the shader error. So what we're going to do here is that, and now find a good way to inform the user. There we go. All right. Okay. Yeah, when there's a shader with time, that's something that will trigger it. So so that's pretty cool. Which is actually something that we should add to our. Well, actually, that's probably one of the things that we should be doing is eventually bringing in our shader variables. But you know, for the most part, that works pretty good. I think this is pretty much what we want. Okay, let's add in our push constant so that we at least have the size, and then eventually we'll be able to do some more of that. Now the other thing that I'm thinking about yeah, I actually want to change one big thing, and for that I'm actually going to do this. So we're back on our default shader. Save. Let's go away with you. And what we're instead going to do is I'm going to add here a new var template shader. I'm going to go and do this. I'm going to go do this and put that over. Oh, okay. Put that over here. All right, like that. Perfect. Sweet. Right. Yeah, that's all good. Shader code is null. Sweet. And then here we're going to say shader code is replace code shader code. Yes. Okay. Right. Obviously, there's a bunch of things that we should improve here, but now we are getting much closer to how Godot does materials. And obviously that's also how the material is eventually going to work. But now we don't even have to include our boilerplate code in there anymore, because most of this is going to be very dependent on all the code here. So, and everything the rest isn't going to be good to implement until we have proper materials. So, excuse me. I think this is very good for what we're trying to do here. So the next thing that we need to do, and I'm pretty sure that I can get that from here. Let's actually go this way. That doesn't really help me. Where are we? Pretty sure this one has it. Please. Yes. All right. All right. All right. For our push constants, so here we're going to add our push constant in. And we're going to go and get our size X and our size Y. So that way we get our render size in. And we are going to go and add our push constant to our compute information. Sweet. So now we just need to make sure that we've got our push constant defined. And for that, I'm going to go over here. This doesn't have a constant. Oh, that one's this one actually uses a raster shader. That's kind of cool. Okay, so that's something that we could have a look at it in minutes. I'm copying that whole thing. And I'm going to go here. And we shall put in our push constant. The difference is that now we're going to go and say raster size. All right, and we're going to say avac2 size is avac2 raster size. Yeah. Okay. And now we're going to say if uvx bigger or equal to size x, or uvy bigger or equal to size y, return. Right, so there we have our size protection in there, but we now also have access to our size, which is nice. Boom. All right, we're gonna get lots of errors there. So, and this is, I don't know if you guys remember me talking about this last time. This is because our push constants are size aligned. So they always need to be in groups of 4 floats. So this is only 2 floats, and it's saying like, "Hey, I'm short." I don't know if the debugger errors are still in there. No, it cleared it out, of course. What about this? Oh, there we go. So it's saying it requires 0 bytes, and we've supplied 8. So why does it think? Oh, because it's probably found it out. So no, so 8 is good. That's actually good. So it's only when you do multiple blocks that it starts to fill in the space. Okay, that's good to know. So let's see if that's. Oh no, it doesn't. Okay. So I was right what I was about to tell you guys. So now we went from requiring 0 bytes because it had filtered it out to requiring 16 bytes of data, but we're only supplying 8. So the reason for that is that even though this is only 8 bytes for 4 bytes per float, it has to be in blocks of 16. So we have to add a dummy here. Actually, in this case, we don't have to add it in the shader code, but I like to add it to make it clear, because these are actually being added automatically. But the real bug, obviously, is that we also then need to add 2 dummies in the push constant buffer that we have here. So we're just going to add 2 dummies in. But again, I do really like to put the dummies in here, or call it reserved is actually nicer. Dummies, so dummy. I do like to manually do it in, put that in, because I just find that easier again to communicate that yes, there are 4 floats here, and that's why I'm adding 4 floats in there. It's easier to communicate. So no more spamming of errors. That's promising. And I should be able to say, yeah, this is so cool. Okay. There is lots more that we should be adding in here, but actually, there is one more thing that I want to do before we stop. Well, before we stop coding, because we can chat for a little bit longer before we call it a day. But seeing we have this, we're actually going to go and say float time. Let's make sure that we have access to our time, because obviously we're making our own shader here. The time variable in shaders is actually something that Godot adds. Now, one problem is that we don't have the what you call it? We don't have the God, what's what I'm trying to say here? We don't have the logic that's going to make sure that we refresh our screen. So we're going to have to fake that one. That's fine. So, but the question is, do we have our tick time somewhere? We should. Surely we have the, we can fake it, but no. No. Okay. So I don't have access to that NGD script. That's interesting. That is a shame. That is a real shame. I was hoping that we could do some animation in here, but I don't have access to that variable in Godot. That's a shame. So we can't do this. I can only do that once I do the implementation inside of the engine. But interesting. I guess that the time variable that I'm after is only accessible inside of the inside of the render thread if this is running in a separate thread. That is a shame. So I think as far as coding is concerned, we're going to leave it there today. Again, the thing that I wanted to accomplish here was to just show that this is possible in this way, and to sort of experiment with how can we make a rendering effect that we can basically base on a shader. And that means that we first of all have live updating. So as we write the shader here, I could do something like times is 0.5. There we go. 0.1. So obviously we can update now the shader code in here, and it updates our rendering effect, which is really cool. That was one big thing, because that also means that I can now do something like, hey, I'm gonna add another post shader effect here, and in this one I'm going to say the color blue is 0. Boom. There we go. So we now have one effect that does one thing, and we have another effect that does another thing. The problem with this right now is you can't do everything with it. I'm going to remove that again because I think that's a bit dumb. Because what we're doing right now is we're doing effects that only affect one pixel. So let's say that I would want to create a blur this way, which would be very possible. I would first have to do a copy, or I would have to do create a temporary buffer or something like that. And we don't really have that option here. Because right now we have hard-coded that we have the color as the input and we have the color as the output. And that's going to be the big thing that we need to start looking at fixing. That if we turn this into material, that we have more flexibility with that. I've got some ideas of how to do that, but I can't do that until I do the versional steroids of this. But as far as this is concerned, this is already pretty powerful. You can do a lot of things with this, and this is obviously where you can get going right away. The video, it's absolutely possible to render through texture. So that's, for instance, well, if you look at my stream from last week, where I go through, actually, why not? Since we're talking about stuff, and I'm actually done with coding in this. For those of you who are watching who haven't seen that, let's go and open it up. Blah, blah, blah. Where are you? Sunrise. So this is a effect where you can see that the sun sort of, the rays of the sun are sort of moving. I hope it actually shows up on the video really good, because it is fairly subtle. Although that might be because I was playing around with the settings at some point. No, are they all back to what they were? That's normal. That's normal. Well, I think I had the sun bigger at some point. 50. Yeah, yeah, that kind of looks better. So that obviously, it's implemented in a single render effect. But when we are looking at the code for that, you'll see that let's make that a bit bigger. You'll see that that goes through a whole bunch of steps. So it starts here, gets our images, and then the first step is it renders a sun disk to a temporary buffer, and then it sort of cuts out the depth buffer in that, and then the next step is it does a radial blur. Then it does the first step of this is a radial blur. Then it's just a horizontal Gaussian blur, and then it does a vertical Gaussian blur, and everything goes from one temporary buffer to the next until at the end it then combines it all back into the color buffer. So this is a good example of doing a multi-step implementation of a render effect, but because this is all done in code and then you have control over it, you can do that. If you obviously make something generic like we just did in our little example project, yeah. So in this one, we're only allowing one pass. So the only way that we could do like a Gaussian Gaussian blur in this is I would need to put two post shader RE effects in here, one for each stage. But I would then need to configure the first to say don't output to the color buffer, but output to a temporary buffer. And then the second one is, hey, the input is our temporary buffer and our output is our color buffer. So, part of this would be coming defining what the input and what the output are. That said, there is a bunch of cool stuff that we can do with that, especially now that we have a template. So one of the things that I could think of is, oh, that's wrong. If you look at our template code, where's my scroll bar? Oh, it's done it correctly for a change. I can do, for instance, let's duplicate this. Boom. So I can do an input image here, and I can do an output image here. And in this case, it would be restrict read only and restrict write only. And what I could, of course, do is I put some sort of define. So if def split image. So we could put some sort of, and this is something that I can do once it's a material shader. I can have that sort of logic. And then obviously we do the same thing here where we're actually going to say that, let's just duplicate that just as an example. So in this case, we are going to read from our input image. And then obviously we do the same thing here. Oops. And in this case, we would be doing that. So now suddenly we have made it possible that together with, maybe a drop down for what we select for our input image and a drop down what we select for our output image, that we can change things. So there's some really cool things that we could do with code like this, where we can make that more generic and make it easier to use this. So yeah, that is basically the sort of concept that I'm thinking about. So I'm actually going to go and copy this. Actually, let's just say blink, blink, blink. Where do I want to save that? Hmm. Because I don't want to lose this stuff. I still want this to work. So I'm just going to undo this. And I'm going to keep that example around for when I want to implement that. But yeah, in this way we could make it easier to chain everything and do some funky things with it. And then just do some drop downs with, you know, what do you do as input, what do you do as output, and in the same way, you know, do we add in the depth buffer, or do we, you know, is it even on the color buffer that we work? So there's a bunch of choices that need to be made in how this code is built. So, so yeah, that's going to be pretty interesting to do. So yeah, I think this is a solid foundation for making a more user-friendly version of the render effects built on top of the low-level implementation that we have. And you know, this as a proof of concept, I think is pretty cool. And obviously that can be expanded to do multiple things. And especially if we tie this into the material system in Godot, I think that we could create some really funky and complex shader things that people can just put together in the normal shader logic. So that's pretty decent, pretty cool. So yeah, that's basically what I wanted to do tonight, and I am pretty excited about how well this worked. Yeah, I'm pretty excited. This is pretty cool. So, all right. Let's see. It is now nearly 1 a.m. for me, so I am not going to stay online too much longer. But you know, if we have another 10, 20 minutes for just for some chatting, I don't know how many people are still actively looking and how many lurkers we have. But if anybody has some questions to ask or wants to bring something up, then you know, then let's see if we can have a little bit more of a discussion going. And else, I'm going to go and find my bed. Well, nobody's active in the chat. I hope that that doesn't mean that my chat has stopped working. Hey, Malcolm, coming in on the last minute. How long have you been lurking around? We need an update of your vehicle video. George, yes, we do. I did do a stream a while ago where I converted it to Godot 4 and got it to kind of work. But I really need to restart that one of these days. But there are so many different things that I want to do. It's not funny. Just the last 15 minutes. You're the one that gave me one higher just now. I'm watching the metrics go by. Um, yeah, I'm still juggling ideas around of what I want to do because like I've said before, the I really want to get back to making some videos, but I think at this point in time, if I am going back to making videos, then it's probably going to be focusing on XR and Godot 4 because we have a lot of content for Godot 3, but obviously a bunch of things change. So there's a number of things that I really want to tackle, and that I don't want to do in a stream because that's a too long format. But I really want to make in some short videos. Stuff like explaining the action map and just looking at the new setup. There's a whole bunch of setup things that have changed. Um, and stream wise, that's where I'm really thinking about doing some bigger things, and especially with the eye on that if I do want to do some videos again about how you build certain games, like for instance the vehicle one. I really want to start those as a stream. I really want to just start building something like that on stream, and then either redoing it separately to record it into a video, or cut up the stream and sort of make a condensed version of it or something like that. But the other idea that I still am sort of toying with is there's a bunch of game things that I was building that I really want to pick up again and redo, or actually just continue on. I was doing the dungeon game. I was having a lot of fun with that. And while that was mostly a proof of concept as far as the mechanics were concerned, I did want to turn it into something proper. I just didn't want to do it with fantasy characters. I was thinking about doing something a little bit more serious than that. But that might be an option that I want to go back to. The other thing that I've been toying around with as an idea for a long time is I did a procedural mesh generation tool many years ago in Godot 3. And I've always wanted to redo that because that was really a really cool project, but where I started with some assumptions because I didn't know Godot as well as I do now. And I really want to redo that and lean much more on doing things on the C++ side. So that would be a really cool series to do, where we really do a deep dive into GD extensions and making a really full-fledged complex plugin in that at the end actually ends up being something that people can use. So that is something that I've been toying around with. Malcolm, when we're looking at render effects at this point in time, the approach is only usable on the 4 Plus renderer. I did add in the option to do something on mobile, but it adds a new path, and that's very unfriendly for mobile things. So we probably need to do something dedicated for mobile. Um, yeah, I don't really know what the benefit is of not using GD script for that sort of thing, but that might be me. Um, Rodzilla, that is a bloody brilliant idea, actually. That would be something. Using compute shaders to generate procedural meshes. In theory, it's possible. That is what compute shaders are pretty good for. Damn. I wonder if Houdini does that, or whether they still do it in software. And if we do something on the GPU, we'll kind of make them jealous. Yeah, Paper Martin, that is indeed. You can do some really cool things in Minecraft, and the fact that that originally it was all built in Java, you know, should be able to do the same in C Sharp. But yeah. And yeah, you stuff with more with threads. I remember that I was doing a whole bunch of things like that in some of the GD extensions that I built, but not sure if that really is very needed for the prop mesh thing though. Because the idea with proc mesh was really that it's an authoring tool, so um, you could build meshes together that are able to be changed by, you know, applying inputs. But then once you have a mesh, you bake it and you use that mesh. So it's a non-destructive modeler at that point in time. Instead of it generating the meshes actually in the game, because the problem that you have if you do that is you know, you get all the overhead that you're constantly rebuilding meshes, and you know, load times become bigger because you're rebuilding big meshes and that sort of thing. So it really is something where in an editor you use a mesh generation schema to create a wide variety of objects that are all using the same code to be generated, but with different parameters. But then you bake them out and you actually save the end result in your scene. So yeah, Godot. When you look at Godot threads, so you can do threads in DD script, which is actually really cool. There's now two ways of doing it. The original way that we use still for things like background loading and stuff like that. Um, you know, you can just define a method. It's kind of actually the same approach as what we did in our shader with where are you? Blah, blah, blah. Oh, we're not doing that anymore. We only did that on the original ones. Actually, where's my grayscale shader? There we go. You know, like the colon render thread. In the same way, you can. I think it is something like. Let's see. Oops. New like this. Yeah, and then it's start. Yeah, exactly. And then you do thread start threaded function, and then obviously that becomes a function. And now that thread gets executed, or sorry, this function gets executed within the context of that thread. Oh, sorry. So yeah, we'll be, oops, will be something like this. So you create a new thread object, and then on that thread object you start it, and then obviously now once this goes and runs, you can do things like the join. I think, do we call it join? What do we call it then? I haven't done that for a while. Wait to finish. Okay, well you can call wait to finish to wait until it finishes. But yeah, and then obviously you can use the mutexes to communicate. So obviously you could do a loop in here. You can do something like, you know, or is running through, and then you can do, you know, while is running. You know, and you can do your loop. And obviously, you know, once you say as running is false, you know, somewhere at the end here, oops, you know, you're doing is running is false, and then t dot wait until finish, and then you get a nice nice cleanup on there. But in the meanwhile, you can communicate with the thread and have the thread do stuff and whatever. Or you can just kick off a thread that just does something, and then when it ends, and it just sort of disappears. So yeah, and that way it's pretty cool how easy threading works on GTscript. The other option, which is maybe even cooler, but which is still experimental, it's still something that we're working on. If you go all the way to the bottom here, I think it's on the process node. Is it there? No, that's not it. Thread group. That's the one I was looking for. So every node in your node tree has a method called thread group, and the default value is inherit. That means that we are running the because this refers to the process code. So every node you can create a process. There we go. Oh, that's not on. I can't do it here, but normally it will be process delta. Because this is a resource, of course. So, but if this was a node, you would have a function called process, and that is run every frame. So before we render, all the nodes process functions are. And the nice thing about this thread group is that you can say on which thread you run that. So in this case, it's on inherit. So it says, okay, I want to run on the same thread as my my parent class. And then eventually, when it hits the root, it is obviously going to be on the main thread. So that's the default. So everything runs on the main thread. But if I do something like this, and I say, and I'm just going to call that node 3D. I'm not going to make objects out of this. Let's say that, and I don't want you under the box. I just want you. Let's say that's my player node, and I have another node here for the weapon that the player is holding, and that sort of thing. So I can now say this player, I want him to run on a subthread. So because this guy is now the first node that has subthread selected, and I can even say whether I want both the process and physics to run in there, or if I only want the process to run in there, or only the physics. Basically, at this point in time, it will run any code on this guy, but also any code on this guy, because obviously he is on inherit, so he gets his thread from the top. This guy is going to run in its own little thread. Now, that is just code that is run every frame, and it therefore runs in parallel with the process on the main thread. So you can suddenly, let's say that you have 500 enemies, and each enemy is not, because of course I can now go and save that as a scene, and that becomes my enemy scene. I can run the code for each enemy, the process code of each enemy, in its own thread. Or, I can group a bunch of them together, and I can have those run in one thread. And while it still runs, right before rendering, it's going to basically start all the executing at the beginning of the frame for that frame, and then it's going to wait until all those threads are finished, and then it's going to do the rendering. All of a sudden, you've got all your actors running code together. So instead of one enemy being processed one after another, you have all your enemy code running parallel, which is really, really cool. But like I said, it's pretty experimental, but it's a really cool feature that was added quite recently. And maybe that's actually something that we could do a stream on. That would actually be pretty cool. Where we create a simple game with a player that runs around, and we create a simple enemy, and we have the enemy running around, and we do some testing on whether how well the enemies work when they're all running in the main thread, and how well the enemies work when they're each running in their own subthread, and whether that actually does some good. Because I have no idea how well that actually works and whether that's going to make a big difference. And obviously, when testing, we're probably going to have a process script that's pretty small, so it might not do that much. But who knows? It's worth playing around with. It's worth seeing if we we can do a little brotato / vampire hunter type game where we get just lots and lots and lots and lots of little enemies, and see how well that works. I have no idea. It was worth trying. So, alrighty. Well, the one I don't even have it on my computer, I think, but it's a Godot 3 one. I haven't started this up in so long. It's. I don't even have my test projects anymore. They are on a computer that got a destroyed hard disk because I do. Maybe there's actually there might be some samples left in here. GD proc. All right, let's see how quickly we can get that up and running. Oh, that was just a snapshot. Do I want to put that on games? Not really. But I want to put that under. I'm going to try to put it in tests. This might be fun. Like I said, I haven't touched this in so long. If this comes down pretty quickly, I can probably open it in Godot 3.5. Let's actually close Godot 4 then. Bye. Where are you? No, it's not going to be in projects. It's going to be in games. 352 should be good enough. Is it in? Yes, it is in. Oh yeah, that's right. I put the zoom in on before for doing one of the videos, so everything's a bit bigger in this one, which I actually don't mind. So we're in projects. Where are you? Oh, really? Projects. Tests. Where are you? GD Pro Mash demo. Yes, I've got a demo project in here. No, oh, of course I need to compile this thing too. Oh shit. Okay. We're gonna have to exit this again. I hope that didn't destroy everything. Yeah. Okay, you can convert all the images. Probably a good idea to do. Let's in the meanwhile go and actually we don't do that like this. How do we do this? I haven't done this in so long. GD ProgMesh. Status. Yeah, that's gonna happen, of course. All right. No, submodule. Init. Yeah, thought so. It's submodule update. And I bet you this is a really old version of Godot CPP, so it might not even run. Oh, this is so old. That's gonna be Godot headers. Okay, so git submodule init again. Oh. Git submodule update. All right. Scans. I bet these are still the old targets. So debug. Is that gonna work? No, it doesn't run. That's because it needs to generate findings. Yes. Yeah. All right, I need to go and yeah, that's fine. Well, I remembered all the stuff. That's at least something. Because that was the way that it was built, is that it generates the meshes, and then it keeps them. And only when you change the template, it needs to do it again. So now I should be able to do a sconce here. No, target is debug. Boom. Gotta hope that's enough. No, that's not enough. Wow. What are you talking about, CL? Now, is this? Yeah. You're not going to tell me that this is too old. These are the older build files. I'm going to regret doing this, am I not? Damn it, I've only got it run as that. No, I think it's too old to try this out just on a whim. Obviously you've got the video on my YouTube where I show how I'm building something with that. But yeah, this is basically you use a node graph to generate a complex model. And you can do some really cool things with that. That's something I still want to rebuild at some point in time, but build files are too old. I guess with a little bit of work, I could probably update it to the latest build file setup. But that's for another day, I think. It is getting way too late, I think. So, yeah, that is one of the ideas that I have for a future for a future stream. There's plenty of ideas. We could do something with threads. We could do something with XR. There's a bunch of things that I still want to do with XR. We could do something like this. We could pick up one of my games again and continue with those. I probably need to restart a few from scratch because I haven't worked on any of them for at least 1.5 years. Which sucks, but at the same time, we've been busy and doing some really good stuff, so can't complain too much. But I do miss it. So yeah. Guys, I think I'm gonna keep it here. I'm gonna leave it here. It is 1:15 a.m. for me. I have people visiting me tomorrow, so I better go and get a little bit of sleep. Thanks everybody for watching. It has been a really good stream from my perspective. We had a really good chat right in the middle. That was really interesting. We accomplished what we set out to do today, which is create the render effect that is hopefully going to be the basis of something nice and easy to use. And we almost were able to rebuild one of my very, very old plugins. I don't think I've touched it. If I read the text here, it says at the bottom, you will need Godot 3.1 or later. So that gives you an idea of how long ago I worked on this. Oh my God. But this was such a fun project to build, and I still regret so much that I didn't continue with it because this was so much fun to put together. And yeah, I think a tool like this, you can do some really, really cool stuff with. So who knows? We might pick that up again. Yeah. Thanks everybody for watching. I hope you guys enjoyed it. I hope you learned something. And I'm still deciding on which day I wanna start doing the streaming regularly. But I am trying to get back to at least a weekly schedule, so at least one stream a week. So you'll see. Maybe for Fridays again, like I used to do. That worked pretty well in the past. So we will see. All right, that's it. Good night, and see you guys next time.